Welcome to Faire, Lake County. We're happy to have all of you joining us here today. We've got a great show ahead for you. Welcome to Faire, Lake County. We're happy to have all of you joining us here today. We've got a great show ahead for you. Welcome to Faire, Lake County. I am having a few. We're happy to have all of you joining us here today. We've got a great show. I apologize for that. I'm trying to get everything up and going on the live stream for the webinar. Having just a few technical difficulties. I'm going to get right back on that. But while I'm working behind the scenes to get that going, why don't we jump in? And we have Preston Frazier here today from Pittsco to talk about drones and how they're being used in different academic settings. So Preston, if you could please join us and share your great presentation.
Good morning, everyone. Can everyone see my screen okay? Good morning, everyone. Hope you all are doing well. I am Preston with Pittsco Education, and I appreciate you all joining me this morning, especially on a Saturday morning. I looked at your guys' weather forecast today, and the weather is a lot nicer where you are than where I am. Here in Pittsburgh, Kansas, where I'm located, it is cold and rainy, but you guys are supposed to get a little bit more sunshine than I am. So I certainly appreciate you guys attending today. Today, for just a little while, we will be exploring a world that will look somewhat like an episode from the Jetsons, or an episode from Star Trek, or even a movie scene or a movie clip from the Star Wars collection. We will be talking about drones. If you have any questions, comments, or rude remarks along the way, feel free to drop them in the Q&A below, and I will try my best to answer them at the end. First off, let me chat for just a moment about Pittsco Education. We are the leading provider of kindergarten through 12th grade STEM, robotics, coding, and makerspace solutions. Our various products, activities, curriculum, and programs promote engaging learning experiences for the learner. We want students and learners everywhere to grow into confident and thoughtful leaders in whatever career path that they choose. We were founded in 1971 by 3 industrial arts teachers, actually 3 industrial arts teachers inside of a garage, who saw that teachers needed an easily accessible place to find hands-on learning kits for their students. If you were to do the math, you would see that we are actually celebrating our 50th birthday this year. Actually, March 6th was our 50th birthday, and so we had quite the celebration here on campus. Some additional fun facts about Pittsco. Since 1992, we have served over 121 million students. We have helped students in over 70 different countries. There are over 1,000 different career paths and careers that are explored within our curriculum and solutions. And in fact, we have our own manufacturing facility here in Pittsburgh, and we produce over 900 and create over 900 different products that are found within our catalog. We sell over 3,000 products, so a little bit under 1/3 are ones that we actually make and create ourselves. I guess that you could say we have our own makerspace lab here on campus. And in addition, we have a proprietary robotics building system, Tetrix Robotics, and it is actually used by the College of Lake County for their Lake County robotics competition. I think there's a couple other sessions here throughout the day where you can actually find out more about that as well. A little bit about me. I have been with Pittsco for just over 4 years. I actually started in April of 2017. I actually started 1 week in April 2017. The week after that I started, my wife had our first kid. So the first couple of weeks that I was here at Pittsco was fast, fun, and rather furious. Some of my favorite areas, because I chat with teachers and students all day, is one of my favorite areas to chat about is aerospace and robotics. As you will find throughout this presentation, drones is really just at the intersection of aerospace technology and robotics and coding technology. And perhaps that's probably why drones are so fascinating to me. In addition, I'm an avid baseball fan, and my goal is to get to every major league ballpark by the time I'm 50. So far, I have been to 14 of the 30 major league ballparks, and who knows, maybe one of these days in the future, I'll be able to fly. I'll be able to travel by drone or any sort of intergalactical flying technology aside from driving a car or flying an airplane. You just never know with the way that technology is changing, for sure. I'm going to start out with a question for all of you. And you don't have to drop your question. You don't have to drop your answer into the Q&A section below. Just think about this yourself. But the question that I want to leave with you guys this morning is, what do these activities all have in common? Surveying storm damage and looking for downed power lines, gathering data on crops and checking for moisture and diseases, filming a movie, delivering a package, melitology and tracking honeybees for pollination. And yes, I did say melitology, and yes, I did check. That is a real word, and it just means the study and the science of studying bees. Fishing, washing windows, delivering pizzas, investigating the insides of an HVAC system, and using infrared technology to help search for pythons in Florida. If you all guessed that these are all activities that I will be doing this weekend after this webinar, you would be absolutely incorrect. Although that would make for a busy weekend, that is not the right answer. If you were to guess that all of those different situations can incorporate a drone in some way, you would be 100% spot on and correct. As you see with these pictures in the top left-hand corner, you see a drone that is actually using a squeegee or some type of cleaning mechanism to spray water on the windows and washing the windows as it scales the skyscraper. As you can see, a lot more safe and more efficient than an individual doing that. In the top right-hand corner, you see a drone in the middle of a body of water, whether that be a lake or an ocean, and it has a fishing line attached to the bottom of it. And someone is actually fishing with a drone. And the way that that works is that someone takes their fishing rod and sets it next to them on the shoreline or wherever they're fishing from. And then they attach that fishing line to the bottom of the drone. And then the drone flies out, and from the radar and technology that it has on the drone, it can actually see where fish are swimming around. And you're able to actually drop that fishing line based on what the radar shows. And then that's how you fish with a drone. The bottom left-hand corner, you see a drone that has some type of flamethrower or fire blaster mechanism on it, and it is actually eradicating large hornets and wasp nests in trees. You also see a drone that is filming a rather action-packed movie scene, and perhaps my favorite photo of the 5 is the drone that is taking rather remarkable footage from the top of a baseball stadium. And if you guys thought that I was lying about the inspection of pythons in Florida with infrared technology, here's a news article that says that drones are helping python hunters find dangerous snakes in the Everglades. It says that a drone startup from Miami has partnered with local Burmese python hunters in the Everglades to use thermal imaging technology and drones to curb the snake population. And from the picture below that news headline, you actually see a man that is actually grabbing a hold of a snake based on him working together with a drone to find where those snakes are. Rather remarkable technology for sure. For some of you that don't know exactly what a drone is or just need a little bit more information, a drone is just simply nothing more than just a flying robot. As mentioned before, they lie at the intersection of aerospace technology and robotics and coding technology as well. Drones are sometimes called UAS or unmanned aircraft systems. What that means is it's a flying object that does not have a pilot on board. They are a tool that will be used across many careers now and in the future. Drones were originally developed for the aerospace and the military industries, but they've quickly transitioned over to more mainstream industries just because they're safe to use and they're efficient to use as well. So this morning, just for the little while that we have here, because they are connected to so many careers already, and because here at Pittsco we focus on career readiness for kindergarten through 12th grade students, we wanted to provide middle and high school students with the opportunities to learn more about drone technology within the classroom. So today we're just going to look at how drones can be implemented in the middle school. We're going to look at how drones can be implemented in the high school and how professional certifications are so important for high school students and especially within drone technology. And then something that I'm very excited to share with you is our conjunction with Skills USA on a brand new drone competition. First and foremost, here at Pittsco, we have developed a middle school grade 6th, 7th, and 8th grade curriculum. It allows teachers the opportunity to introduce drones in an easy and non-intimidating way. Each activity within the curriculum has a career focus and an autonomous and coding flight portion. And there are also competitions after some of the activities that are focused on developing additional skills. With all of that in mind, even with the curriculum breakdown that you see there, what I'm most excited about is the careers that are focused on within this curriculum. Naturally, we explore drone pilots within this curriculum. Software developers are explored within this curriculum. Drone curriculum that we have here, construction inspectors are explored. Air traffic controllers, photographers, videographers, electrical power line installers are explored. Urban planners, power plant operators, land surveyors, wildlife biologists, and firefighters are all explored within this curriculum. You can see here that drones touch so many different industries, and they're going to touch even more in the future as well. In addition, here within that curriculum, we have what we see here. We have a drone arena, and we have field elements that go along with that drone arena. Different elements and different obstacles that the students can fly through and perform different tasks with. There's hoops and landing pads and different perches and landing spots and all sorts of fun stuff there. However, I don't want to take away from the fact that this curriculum package encourages a maker mindset for sure. First and foremost, there is the opportunity for the students to create their own field elements for this drone arena and for this curriculum. Here at Pittsco, about 7 or 8 months ago, we had an employee-focused competition to where a team of 2 employees would get together and we would try to create our own field element for the drone arena. You would be amazed at all the different things that we came up with, tunnels and hoops and all sorts of different and creative things. Students can certainly do that as well with this. Second, most drones can be coded, whether that be with Arduino programming or Python programming or Swift or Scratch or Java-based programming. This allows for a design and mapping portion of the drone to where they can create and map their own flight. They can determine what went wrong with their flight. They can troubleshoot, they can problem solve, but at the end of the day, they make their own path and they create their own way to have that drone fulfill a specified mission. Third, there are many ways to incorporate 3D printing into the use of the drones. You can create different parts for the drone. You can create different mechanisms that hang down from the bottom of the drone with a 3D printer. There's so many ways to make and add on to a drone than what you see here. In addition to our middle school curriculum, we also have what we call our remote pilot certification prep course. And this is for high school. And this is an aviation industry focused curriculum. We've talked about all of those careers that drones can focus on within an industry. In order to focus on some of those careers, you must be safety certified. You must be certified in some way in order to fly a commercial drone. And so this curriculum certainly helps with that. This curriculum has FAA standards throughout and prepares students to take the FAA, the Federal Aviation Administration, Part 107 certification exam. It exposes students as well to many different drone-related careers. It's written by certified professionals as well. And the program is just meant to prepare students to take that exam. I like to compare this course very much so to a driver's license, driver's education course in which the students have to take the driver's ed course before they can go and take their driver's license exam. This is the same thing. It's the flying education course before you go and get your drone flying license. It's very important. Certification is very important for high school students and people in general. And this is just a way, just an easy and quick way for them to get that certification. You can see here some of the curriculum highlights from this remote pilot certification prep course. You see detailed lessons, STEM-based curriculum, rubrics for easy grading, multiple formats, easy adaptable to other curriculum within your class. But at the end of the day, it certainly encourages that type of creative and problem-solving mindset that students need in order to grow in their careers, for sure. The last thing that I am certainly excited to share with you about is our coordination with Skills USA. And for those of you that don't know Skills USA, you know that it is an organization that really encourages industry-focused approaches to student learning. So there's a bunch of different activities that can go on within a Skills USA chapter, from cabinet making to diesel mechanics to interior design to fashion design to robotics. We've actually helped with the Skills USA robotics competition as well, the urban search and rescue competition that we've actually spearheaded for the last 10 years. So there's a bunch of different skills within this organization, and the most recent competition that we've been a part of with them is the commercial SUAS competition. And this is, we are part of the planning committee. So we have been working in coordination with Crossflight Sky Solutions, Mind's Eye Drones and Robotics, the University of Florida and their College of Engineering program as well. And the commercial UAS drone competition is really summed up in 4 succinct tasks. Students fly a drone through a specified arena to fulfill a mission, much like the middle school program, just a little bit more extensive in that sense. The second task is where they actually get into a little bit of the troubleshooting, maintenance, and repair of a drone. They start learning more about the intricacies of how a drone operates and how it works and how to solve those problems to get a drone flying again. Task 3 is all about the FAA knowledge test. So this competition is very much so industry focused, where it tries to teach the students many of the safety rules and regulations for the FAA. And then task 4 is what I call the design and mapping, or the autonomous flight portion, where they actually have to use their coding and programming acumen in order to design and map a specified flight through a mission field per se. And then they're graded and evaluated on that, and then they're awarded on the way that they perform within that competition. The purpose of this competition is to evaluate team members' skills and preparation for employment in multiple drone-related career fields related to the safe and efficient use of drone technology in the national airspace system. And so if you were to look at a day in the life of the national airspace system, you would see thousands and thousands and thousands and thousands of airplanes that are flying from city to city all over the country. But then on top of that, or below that, you will see millions and millions and millions of drones that are flying, and thousands of drones that are flying as well. So obviously, with drones becoming more prevalent within the national airspace, safety and certification is certainly suggested for flying a drone. Exactly. So that is all that I have for my portion. Is there any questions, comments, or rude remarks that anybody has? If you can, please feel free to enter them in the Q&A chat window.
Hey, Preston, we did have a question whether or not there are any drone programs offered at the elementary school level.
That is a really, really good question. And that is, that's something that we are currently working on. When I say that the middle school drone program works in 6th, 7th, and 8th grade, that just means that standards are met within that grade level. So that doesn't mean that our 6th, 7th, 8th grade curriculum won't work in that type of environment. It certainly could have the chance to do so. It just doesn't meet any standards within that grade level. You can certainly use the drones in like a 4th and 5th grade setting as well, if that makes sense.
Then we also had, I think, more of a comment than a question, but did you see the drone footage from the radio telescope antenna collapse?
I have not seen that one. There's many different drone footage coming out, even more so now. You can go every day and look for drones and see something new. So I haven't seen that, but I'll certainly explore that. I was just flabbergasted by when I saw the drone technology being used to hunt pythons in Florida. That's really, really cool. There's so many careers tied to drones at the moment. Any other questions?
So as we commented, certainly go ahead and type any questions that you have in the Q&A for us today. Well, Preston, I do appreciate you taking the time out this morning to share this information with us. I know we've had different guest speakers come to talk about the engineering disciplines here at CLC, and I've been surprised at the variety of ways that they've come up with talking about using drones, especially with civil engineering, where now they're doing a lot of their field work and their surveying, taking advantage of drone technology as well, and as well with some of the LiDAR. So I'm sure we'll continue to hear more about drones and the variety of uses, although there is the good random comment about calling drones skeet. So certainly not everybody appreciates drones. They can be a little invasive, I guess, and from a personal privacy aspect, that is something to, I'm sure we'll also hear more about as things go forward.
Yeah, for sure. Thank you guys so much for attending. I certainly appreciated the opportunity to come in and chat for just a little while and just kind of talk more about drone technology. Thank you guys so much.
Okay, have a great day.
Thanks.
So certainly, as we welcome all of you to the various sessions that we'll be having today as part of our Maker Faire, probably the best thing to do is to check out our schedule throughout the day. Right now, you are attending the sessions in track 1. So if you go to the Lake County Maker Faire schedule site, you can go back and forth. So right now we've got track 1. Our drone talk just ended. We'll be talking in a few minutes about vector portrait drawing. And then we've got amateur radio coming up. and citizen scientist all before lunch. I would encourage you to explore these and then also take a look at the other track. So when you registered through Eventbrite, you would have received links to both tracks. Track 2 this morning is focusing a lot on the robotics that have been happening in the area. So the 4-H robotics, I believe there were 6 different schools that have been working with ED3 robotics to do a variety of challenges. That's going to be followed by some high school students that have taken on doing some robotics in their home. As many things this year, we've kind of grown to adapt. And so it would have been school teams in the past for robotics. We've offered these individuals kits where they've taken them home. And then some of our students in the engineering program here have been their mentors, and through Zoom really walked them through the programming and various aspects of putting their robots together. And it's really been amazing. I saw some video footage the other day of what they've accomplished and what they've been able to do. So we have about 5 minutes right now. We are just going to take a short break. And at 10:35, we're going to jump in and do vector portraits. What I would encourage you to do is go out and check out Make Projects. So on our Make Projects website, you'll see a variety of maker fairs are listed. The Lake County Maker Faire shows some of those robots that I was just talking about. You can click on any of these links and watch the videos. You can see some of the Make-a-thon entries, which we'll be highlighting a little bit later as we talk about the winners, as well as some area programs at local schools or individuals who have been making some great creations. One of the things we considered as we put together this format is how can we really engage with the community when we can't all come together in one space? And so one of the really interesting projects that was put together here is interactive digital art. And you have the opportunity to interact with other people in the community. So go ahead, open this up, pick a project. So for example, I'll pick this one right here, and you can grab these erasers or pens and go ahead and start coloring in some of the artwork here. And we'll have various people working on it throughout the day, and hopefully we can come up with one very cool collaborative community artwork. And as I said before, if you have any questions or comments, go ahead and put them in the Q&A. So take a minute. I'm seeing some questions about navigating the website. So certainly, as I said a minute ago, as you go back and forth between track 1 and track 2, you can see the lists. If you wanted to be watching something that's currently happening in track 2, you can certainly click watch live and it's going to bring up the web page and you'll be able to watch it from there. Otherwise, if you registered through Eventbrite, you would have a separate Zoom link, and that will enable you to interact with the Q&A. Not all of our attendees, or sorry, not all of our presenters were able to join us today. So some people did send ahead some videos. And so I'm going to share with you now a digital drawing vector portrait video that was put together by one of our local educators. Erin is a tech educator, meaning that she helps to support the teachers at her school with various types of technology. She also teaches some summer camps through the CLC Explore program in graphic arts and in photography. So I want to share the video that she put together. Go ahead and put that at full screen.
Hi, my name is Erin Lopez, and I'm going to show you how to use Gravit Designer, free version of the software, to create a vector portrait. And below, you'll see that there's directions for the link to the Gravit Designer website and also the web address for the vector portrait directions. Let's take a look at the software. When you are logged in with your free account, you'll start off with this dashboard that allows you to choose what type of design you're going to work with. For this example, we're just going to use a letter size portrait. And what we're going to do is we're going to get the graphic in there. All of these directions are in that link that I provided. So I'm going to place the image. And what I'm going to do is I'm going to give you some tips because all the other directions are going to be in that web address I gave you. So one tip that I believe can help you is when you have this graphic in there, if you go over to your effects and you click on color adjust, it's usually helpful to bring down the saturation and to up the contrast so you can see almost what looks like a vector portrait, but this is not what we're trying to do. What we're trying to do is to be able to see this photo in shapes, because what you want to do is you want to dissect this photo and you're going to be drawing a bunch of different shapes. Like on the example here on the left, you're going to draw different shapes to fill in with color. So you notice on the right, here's the example where, for example, the hair. You had to draw the shape first and fill it in with a color, and then you stack your shapes and layer them and color them so to be able to get to your final product. So in order to do that, it's sometimes easier to see the different shapes in there that are created naturally. Off to the left here, you have your layers. So over here on the left, it's original. It says original. You can rename it by double clicking on the name. And I can just, let's say this photo original. So I know it's the photo. There we go. And you can also hover over the lock to lock it so it doesn't move on you. Okay. So what you want to do is you want to start creating the shapes by using your pen tool. So underneath your pen tool, you have the option for the free version, pen and freehand. So let's see what it looks like for the freehand tool. So I chose freehand, and right now the color of the freehand is going to have a white fill and a black outline. That's going to be really hard to see in a black and white photo. So I'm going to click on that, and I'm going to choose this magenta just so it's easier to see. And let's draw the hair. So with my mouse, I'm just drawing around, and I'm going to get the hair in a shape. So this is not as good as the next step I'm going to show you, just because it's really hard with the mouse to draw freehand. I could also be going a lot slower, and it would probably come out a lot better. And I always want to go back to my starting point. So I want to end with my starting point, so I make a closed shape. So now notice, because I closed it, what it did was, in fact, let me change the fill so that's a little bit more obvious. I'm going to make it green. So notice what it did. It's that it filled it, it created a shape, and the shape is movable. If I go over to the top and grab my selection tool, it depends which one. Normally it's going to be on this pointer tool or pointer. I can go and drag it and move it around, and I can see what I created there. Okay, so I have that there. I could also now notice in the layers panel here, I have a path. So maybe instead of the word path, I actually rename this and I call it hair. So that's another tip in addition to the directions here that might help you if you name it and if you lock them as you're working. So notice that's there. If I hide it, just to get out of my way, I can go to my pen tool, and my pen tool is a little different. The pen tool works like this. If you click and drag, I can make a curve, and I can close it. I can go to my pen pointer tool, and instead of pointer, I go to subselect. I can grab my subselect and move those around. This here that I'm moving now is called a handle. Your handles can adjust your points and your curves. So I can move it by grabbing the anchor point, or I can grab my handle and move that. I'm going to delete that. So notice if I go over, let me delete. If I go over to my, let's say I want to draw my face with my pen tool selected, notice when I go and I make curves, it's a little easier to get these shapes. I'm going to ignore the hand because I'm really just trying to get the shape of the face, because I'm going to make that its own layer. Notice I'm going to close this here. And now I have the face. I'm going to hit escape to close that out. And then I'm going to go to where it says path, and I'm going to call it face just to make it easier. And I'm going to turn on my hair again. And I want to show you one more thing that I think could be helpful. If I move my face above just a little bit for the sake of this, if I decide that I want my hair to be on top of the face, I can go over to layers and I can move that layer up. I don't want to move it. Oh, I'm getting a save to cloud. That means, do you want to save it? You probably do before you lose it. That's cloud. You could also save it to your computer as well. But let's get back here to the layers. If I want to move my layer up, I can click, hold, and drag and move it above the face. And that can help with your ordering. So notice now the hair is on top of the face. Let's say you now have read all of the directions. You go through and it gives you some tips on what to do with different spots and how you can create a real like finalized look here. Notice the different shadows on there. And you can look with the eye, the detail in there. You can take this as far as you want to. Okay. So the directions give you all these details. Let's say you're all done and you're good with your final product. You can go to File, Export, and look at all the different versions you have to export. You can export as a JPEG, a PNG, an SVG file. So this is great for if you want to design something that you're going to print on a different type of printer, like a laser engraver or a vinyl t-shirt maker, let's say. You can use these other file formats to be able to export your designs in the file format that's suited towards the machine that you're using. So you save it the way you want. You can save it as a JPEG, and notice you could save it to your computer. You don't have to save it just on Gravit. And there's a lot of other things you could do here with the software, but starting with a project like this helps you with creating shapes and layers and colors and a lot of the basics of using the graphic design software that allows you to create even more cool projects for the work that you do.
Well, I hope you enjoyed that video that Erin put together for us. And there certainly are a lot of tools out there that you can take advantage of to start making some of your own creations. I'm seeing that we've got our other guests here joining us from the McHenry County Wireless Association. I would like to introduce David, Dan, and Ralph, and hopefully Jen will be along shortly, and give them this opportunity to share their amateur radio in the 21st century presentation.
Well, thank you and welcome. My name is Ralph Iden, and my amateur radio call sign is WB9ICF. Amateur radio or ham radio has existed since probably the early 20th century. And like a lot of our modern technologies, has evolved significantly over the years. I'm going to take a few minutes now and share a little background, and then we're going to turn it over to the other presenters to provide some demonstrations. So in the late 19th century, amateur telegraphers began setting up their own private network systems. This was based on the early Morse code, Samuel Morse, and everything was wired. But when Marconi demonstrated that we could use radio waves for wireless telegraphy, things started to take off. The interest in this technology led to rapid expansion, and soon many thousands of transmitters were in operation by 1910. This became a problem for commercial and military radio systems because these homemade transmitters used a simple spark gap design, and it tended to spray their signals across a wide part of the radio spectrum and causing interference. So because of that, Congress passed the Radio Act of 1912, which restricted private or amateur stations to frequencies 1.5 megahertz or higher. That's just near the top of our current AM broadcast band and upward. These frequencies were deemed useless at the time, and because of that, a number of radio amateurs in the United States dropped by almost 90%. However, radio amateurs, the experimenters that they are, set out to overcome these challenges of operating on these useless bands. Today, there's around 3 million licensed radio amateurs worldwide, with over 760,000 here in the United States. In the early 1900s, a typical radio transmitter would be a spark gap transmitter, like the photograph on the left, if I can switch over there, like the photograph on the left. The high voltage spark is generated inside of the globe, towards the right of the table. But as years went by, vacuum tubes were invented and began to be used in the amateur radio stations. So the result was a lot better performance, greater reliability, and vastly greater communication ranges, because it was discovered that the signals on these previous useless frequencies could actually bounce off of the ionosphere and could be received around the world under special circumstances, under the right circumstances. The photograph on the left is an example of a vacuum tube radio station, probably from the probably late 50s and 1960s. This amateur, WB6ACU is this call sign, happens to be musician Joe Walsh from the Eagles. Joe is very active and continues to be a vintage radio collector. With the evolution of the transistors, radios got smaller and became more portable. And this made it possible to take amateur radio to places where we couldn't go before, for example, Pikes Peak in Colorado. In the 21st century, software-defined radios are the next big leap in technology, because it has the ability to adapt to new communications modes just by changing on how the signals are processed using software. Full-featured radios are also highly miniaturized and can be taken almost everywhere. This radio on the left is handheld, is about a third of the size of the one that I used on Pikes Peak, but with loads more capabilities. The Raspberry Pi whisper transmitter, it's on the right there, has transmitted signals up to 1,900 miles, just using a piece of wire for the antenna. Homebrewing or building things or making is another fun thing that some amateurs do. And this is something that I particularly enjoy doing. Excuse me. Amateurs have played significant roles directly or indirectly in almost every major technological advancement that has been made. Perhaps had the amateurs not be given those useless frequencies back in the day, we may not be as advanced as we were or have gotten to where we are as quickly. Moreover, when natural disasters or emergencies occur, amateur radio operators are often the critical first communication link. When Hurricane Maria hit Puerto Rico in 2017, amateur radio provided a vital role establishing communications on the island, as well as between the island and the mainland. Many amateurs are also part of the weather spotting networks here in Lake and McHenry counties, and we provide communication support for events like the Chicago Marathon. A lot of makers in the community are also licensed radio amateurs, such as Lemore Freed, Jerry Ellsworth, and Becky Stern. Becky Stern, by the way, has written a few instructables recently, including one from March of 2020 about amateur radio. Amateur radio provides endless opportunities for learning and enjoyment, and I hope that you will find that it may appeal to you as well. So now let's hear from Dan, who will tell us about a project of his, or Doug.
Greetings, Maker Faire. I am Doug Tucker, KD9PQI. I recently earned my amateur radio license, and I've had a lot of fun making contacts with other people. I originally wanted to get it for emergency preparedness in the event that there's a natural disaster or the cell towers go down. I'd still be able to communicate with other people. And what I quickly learned is that this is a fun hobby, a good way to meet others, and a great way to build fun stuff to improve the way the radios work. This is my first radio, this little handy talkie. It'll go a few miles, but what I found out is if I build a bigger antenna and put it up taller off the ground, I can reach 10 to 20 miles with the same radio. I recently did that with a scout group where we communicated about 20 miles away and had a really good signal. So I'm going to show you how to do that today with some basic household materials. What I'm going to use is some copper wire. I've got some screws and a piece of wood to hold it all together. And then the coax that I'm going to use to connect this just has some quick little ring connectors. So I'll start putting this together with the ring connectors. The coax is separated. So of the two wires, I just have one wire going to each terminal. And you can make this out of wood or PVC, any other materials. Some people use PVC because it's going to be a little bit more weather resistant. And this is actually two antennas. I've measured this about 19 inches for one frequency, and the shorter leg is about 7 inches for another frequency. And I'm going to tighten these down. As you can see, there's really nothing too complicated about this. You just have to have the wire the right length. Copper works pretty well, but other wires work. I've even used a coat hanger. Now to get this off the ground, I'm going to use this little pole right here. And I can raise this up. You can have this go as high as you want to. Any height above the ground is going to help. Now that we have our antenna built, I'm going to connect it onto here. I have a coax connector that goes right onto this radio. And the nice thing about these radios is you can hook different antennas on, just need the right connectors onto the coax. And we're ready to make a contact. CQ, 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 KD9PQI.
KD9PQI, this is KD9WEW.
Hello, I'm just testing out a new antenna that I just built. How do I sound?
Hey, your signals are 5.9. It sounds good.
Excellent. I'm making a video for the Maker Faire showing how easy it is to build a portable antenna.
That sounds really interesting. I hope others are encouraged to explore ham radio and all that it has to offer. I'll let you get back to your demonstration. Have a good day, and I'll talk to you soon. KD9WEW.
All right, thanks for the contact. Enjoy your day. KD9WEW, KD9PQI, clear. Well, there you have it, folks. With some scrap metal, little pieces of equipment you might have around your house, you can make a radio like this much more powerful and reach further distances. Well, I hope this has inspired you to learn more about amateur radio, knowing that your next contact might be across town or around the world. Well, stay tuned. My friend Dave, K9AT, is going to show you how to use a little radio like this to communicate all around the world.
Hello, David Holmgren, K9AT here. Just wanted to put together a little video about a topic for ham radio that might be of interest to the Makers Faire. Actually, with ham radio, most people identify ham radio with talking long distances. And the little secret is that you have to have propagation. And propagation is a result of the sunspot cycle, which peaks every 11 years and then goes to a lull at 5.5 years. So what do you do in the meantime when it's at its lull and you still want to talk to people around the world? Well, there are options for that. And those options are using the digital modes. And there's various digital modes out there, which I really won't cover for this video, but they're pretty cool. D-Star, System Fusion, DMR, and P25. Those are digital options, which will let you connect a local station on VHF and UHF to someone else around the world. So that's pretty cool that you can do that. But I've lately become interested in a new method, which is called All-Star. And what's nice about All-Star is that it's actually an analog signal, which has analog characteristics. So there's no digital compression, which some people find a little hard to understand. But analog is always great. It sounds good. And what's neat about it is it's analog that can be transported through the internet and be heard anywhere around the world. Now, All-Star is something that loads up on a Raspberry Pi, which I'll show you in a video here. And once it's configured, and it's free software, and if you've got the compatible radio, you can get going right away and connect up to other nodes, as they're called, in the All-Star network. So without further ado, let me just kind of show you what it looks like when it's running. This is actually a Raspberry Pi. Raspberry Pi, it's got all the connectors on it. I know these are very popular in the Makers Faire. And but this one's kind of a unique Raspberry Pi. It actually has built-in radio frequency deck. So this is the part that transmits. That's the little antenna. And this can be run either with a Cat5 cable hooked up to it, or you can be Wi-Fi. So this is just one method. This is a low power Raspberry Pi that you can access and talk with one of these types of radios, which is an HP. And so what I'll do is I'll just transmit real quick and you'll hear it beep and come back here. Now, there are other types of All-Star connections. This is a, I guess you could call it a high power solution. You can go up to whatever the power capability of the radio is. And in this case, this is a Linko. It'll go 50 watts. And you can see hiding back there behind my desk is another Raspberry Pi. And that one will connect up to a radio as well. So this one will cover around the neighborhood or even around town, depending upon how much more you want to run this transceiver. So how do you get started with All-Star besides this Raspberry Pi stuff? Well, what you have to do is you have to go to the All-Star website and register. And once you're registered, you can get a node. And then once you get registered, you can actually go in and take a look at the list. And on the list, this is where all the other nodes are displayed. Okay, so let's take a look at that hotspot node that I've got set on the desk that we just looked at. And that's it, it's 52649. And so when I click on that, it'll say that there's no connection. Well, let's connect to something. Okay, the nice thing about this Raspberry Pi that runs next to me here is you can use an app on your phone, whether it's Android or Apple, and you can connect up to wherever you want to go. So I did that with the app, and now what I'm going to do is I'm going to click on the bubble chart and watch what happens. And what it does is it shows all the interconnections to everything around the world. And so I am in here, I think right here. There we go, that's me right there. And so this is pretty much where everybody's. And so if I click back out, you can kind of see what's going on here. And so this is kind of an idea of where everything is going and where you're connected. This is a gigantic room. It's called the East Coast Reflector. And all rooms aren't this big. You can create a little room just with your local friends or people that you want to connect up to in various states or around the world. Now, just as an example here, I'm going to make a video of me talking to the East Coast Reflector. And so all I have to do is grab my HT that we connected up with and give a call. This is K9AT listening on the East Coast Reflector. Is anybody on frequency?
P4 FXS Mobile in Lake County. 4 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 FXS Mobile in Lake Co
Hi, thanks for coming back to me. I'm making a short little video for the Makers Fair up here in Lake County, Illinois.
Florida, I'm near Sorrento, Florida. Over.
Okay, very good, very good. My QTH, by the way, is Ingleside, Illinois, part of the chain of lakes in northern Illinois and Lake County. Go ahead.
Well, I'm kind of a long ways out from Leesburg. This is WP4FXS Mobile.
Okay, yeah, hey, no problem. 73, sir. Have a nice day, K9AT. So there you go. There's a good example of an all-star connection. We talked to somebody down in Florida, and I was just using a little HT, and we made it work. And obviously, the transport in between is the internet. And on his end, he was in a mobile, driving down the road, going into a repeater with another all-star connection. So that's what's pretty neat. It's a lot of fun. It's just one example of one of the many facets of ham radio, which is a fascinating hobby that I encourage you to get started in. It's something you can do whether you're young or old, and it's a great, great hobby, and you learn a lot. 7-3 from K9AT.
Thank you. Well, we learned about using Morse code in the early days, and that's actually still used to this day, and voice communications, both over the internet and direct. But now there's other ways that we could use to communicate between each other using amateur radio. And for that, I'm going to turn it over now to Dan, who will describe the ways that that can happen. So with that, Dan, please share your screen, and I will mute my mic.
All right, thank you. So I'm gonna turn this on as I get all the pieces going here. So I got a couple of slides. So some of the people have talked about digital modes. The digital modes I'm gonna refer to are used for not necessarily going through the internet, but they could. Some of those modes, as Ralph had mentioned, was CW. It's one of the first digital modes that actually existed, and is also known as Morse code. And it's a very, very functional, very useful system to be able to get out. Some of the other areas of digital modes that are used are PSK 31, which you could actually do a keyboard interface and talk back and forth, almost like an internet chat going back and forth with each other. Other modes are RTTY as well, radio teletype and functions. So this has been used for quite some time, but also still used in amateur radio, some areas. And with most of these systems, as everyone figures out different ways of communicating, different ways of testing applications, there's always new modes that are coming out. So FT8 and FT4 are some of the latest modes that are coming. And it's more of a simple connection, giving signal strengths and location and kind of a feedback back and forth to each other. Taking some of the huge benefits of FT8. So a lot of these have a lot of encoding happening so that they can be used in very low signal strength or in high noise floors and get long propagations with the system. So using some of those systems, we've actually changed it to interface more like PSK31, which is JS8 call. So you can have more of that keyboard interface and be able to talk back and forth to each other. And then, as Ralph had mentioned, is Whisper. Whisper is very, very useful for testing antennas and testing filters, testing different functions and seeing how well they're working, what propagations are out there and directions that things are going. And there's many, many other digital formats. Constantly new ones are coming up, and could only mention just a few of these. When we're talking about some of the simple ways of making different systems, so these are two boards that I've actually made for CW. The one on the left is by a company called Cricket that you assemble the whole system. The inductors are actually coils that are made into the PCB board, but then all the filters are created with the capacitors that you've added, and then the op amps on the system for the audio feedback from your side tone of Morse code, and also what you're receiving from the RF link. And here's your little crystal with your resonator that's feeding in. Here's a little jumper so you can plug in multiple different crystals depending on what frequency you want to use. And off the side, it's using just a standard piece of FR4 that's bolted down with a single, as you call it, the old fist, bouncing the key to create your Morse code. So a very simple circuit that can get you up on the radio um, in a lot of functions. Some of the other areas on the right is kind of a Morse 32 that is very useful, especially for people trying to learn CW. I built this board up, and some of the nice features of it is not only does it have some training modes in it where you can actually do some recording and testing and feedback, but it also has an antenna on here so you can use LoRa, so
Hey,
long
Dan.
range wireless communication. And
Dan, if you don't mind, I'm going to interrupt for just a second.
yeah.
I think you're trying to show us some really great things, but we are not seeing your screen.
Oh no.
So you've got some great descriptions, but we're not getting the visuals.
Let me get the screen share and double click again. Like Zoom always. Hopefully you see it this time.
Yes, we're seeing some nice imagery.
Awesome. Okay, well, here was the modes that I kind of went through, but hopefully those are the names if you didn't quite understand the verbiage. But yeah, so here's the two boards. The one here on the left is the Cricket board. The one on the right is the Morserino that I was just talking about. And the antenna is designed for 432 for LoRa, long range operation. And some of the nice features with this is even if you don't have your ham radio license, you can use this to kind of train and talk to some friends and be able to communicate back and forth. You could also connect it up to the internet and be able to communicate over the internet with somebody else trying to learn. So lots of boards and pieces out there. And kind of an idea of what the circuit looks like, you know, for doing a simple CW circuit. It's very, very simple when you look at some of the ideas. You know, some people may see this as complex, other people as simple, but a lot of pieces are out there. As you can see here, here's your antenna connection and just a low pass filter that's coming through. And off of this section on the right, when I talked about the crystal and oscillator feature, this is what's creating your frequency that you're generating that's going out onto the antenna. And then each time you press the key, it's creating a side tone, which is what you can hear so you can understand that you're keen and get your own signal coming back. And also when you're in the receive mode, this oscillator is being used to create your tone for picking up what frequency off of through the RF for other people communicating back and forth. So some very simple, crude circuitry that you could easily put together or even buy a kit and put together and see exactly what's going on. As I mentioned, you know, PSK31 is kind of the digital interface, kind of keyboard to keyboard functionality. Seeing exactly how these pieces go back and forth and be able to communicate. So it's almost like your internet relay, but this is completely over just RF that's out in the system. One of the systems that I've kind of come to appreciate quite a bit is FT8, FT4, and with JS8 call, is it's using some propagation and encoding to be able to get into the very low noise floor with this system. And to give you some ideas of what the interface looks like, and this can run straight off of a Raspberry Pi WSJTX, which is what I normally end up having on when I'm remote. In my actual shack, I'm running it off a Windows PC, but with Raspberry Pi, it works quite well and very, very useful out in the field. You can see here the red is transmissions back to me and a complete contact. So I went back and forth with this person for a nice contact. Just the other day, I ended up having a nice contact, and I find this very interesting as you're going through and having contacts and trying to find out where people are. So there was an island that I had never heard of before. You know, my geography is not as good as it should be, but I keep expanding. So here's Madeira Island that I was that's part of Portugal. but it's a complete independent entity of Portugal, and you can see exactly where it is. And so I find this very interesting, seeing exactly where you're making contacts with different other ham radio operators that are out there. The other really nice thing with using digital modes is it's a good way to find out exactly what the propagation looks like. So this was a little bit earlier this morning as I was doing some propagation on all the bands, but you can see here 20 meters and 40 meters. So most of it, the propagation wasn't too good going over to Europe, but most of the time in the evenings, I'm doing pretty good getting propagation over into Europe as well. And here was, evening hours, on 40 meters. So it was, 20 meters would have been better for local US contacts, but as Europe was coming into the dark zone, a lot of times 40 meters does better at night. So I was able to get some good propagation over to Europe and see some feedback. So it's a good idea to get feedback where you're getting signals out, and also as you do tests with different antennas and see exactly what pieces look like. Talking about quickly the antenna that was being used for this, it's a simple vertical antenna that soldered. These are the ground wires that hook up to the bottom of the antenna, and you can see the picture of it. So they just hook up around the bottom piece, just kind of create a little area for spreading the antennas or the radials out. Have a fiberglass mass that just holds up the wires, and each of these wires are resident, just like Doug had talked about for 2 meters, but pushes up for all the 10 meters, 20 meters, 40 meters, and you could create it for other bands. And this is a live screen of exactly what's going on right now. And as you can see, these are different signals that are coming in, different people that are going. But that was a real quick propagation. And get that to stop. And I can send this back over to Ralph. So definitely hope you're interested in learning more about ham radio digital modes and all the other pieces.
Well, thank you, Dan. Appreciate that. And, you actually bring up some really good points in that amateur radio is has a diverse set of people that practice and enjoy the hobby. You can be an engineering type, very technically oriented, but you can also be someone who is just a casual operator, is just learning about things or just wanting to talk to people in conversational mode. So it's great. There's a place for everybody here with amateur radio. And you may have gotten the impression that all we do there is sit around and in our what we call our ham shakes, or we don't really get out in the world and don't do much with amateur radio. But that is not the case, as Gary, our next presenter, learned recently.
Okay, Roger on that. I got you 5'9" over here in Northern Illinois. Parks on the Air, sitting here at the park K178. You sounded good. Thanks so much for the QSO. I really do appreciate it. QRZ, this is KD9FMJ. Hold on, I'm going to QRT for a minute. Hold on a second. There.
Hey, ma'am, I see you're using some solar panels over here. Tell me what you're using for?
Yep, those are solar panels, and they are actually hooked to my portable battery here, which is then charging a radio I'm talking.
Really? So, did you buy all this, or did you make something here, or
Well,
what's in the battery box? How does that all function?
The solar panels I built, and then I had actually purchased the battery that's inside of this box. Sometimes they call it an ammo box. And so I ordered this box, and I actually went ahead and did a lot of building on my own for this. As you can see, I actually drilled in, and you could see I had my cell phone plugged in, and I've got a gauge here that tells me what it is. And then also I drilled in these two, and I hooked up what these red and black things are called Anderson power poles. They're very much used in amateur radio. They can sometimes be used in robotics, model railway, things like that, because what's really nice about them is anyone can show up and you don't have to have a certain type of plug. So as you can see, I'll unplug the solar panel, and I actually put these on, and you can see that basically both ends just snap in together.
So that's kind of like the electrical standard for doing this kind of
Yep,
build
that
and
is.
things.
Yeah, for anybody who might show up with any kind of radio. And then what I have inside here, this was actually, you can't quite see it, but the battery is underneath here, and this is called a solar controller. So what this is doing right now, you can see the solar panel is hooked up, and it's actually showing that it's charging my battery from those solar panels. So I basically can work all day as long as I have sunshine, and then this will keep
Keep
charging.
your battery charged up.
But you have to have a solar controller because then you don't overcharge your battery. This is a lithium iron battery, not ion, lithium iron battery.
Is there something special about that lithium ion battery?
What's really nice about this is when you charge your battery and you use it for any kind of, if you're using it for any kind of auxiliary power, it stays at like 98% for a long time before it drops off. Whereas if you use other batteries like a deep cycle, it just kind of keeps going down on a regular kind of a trajectory. So
Okay.
that's why these are nice.
Yeah, and it looks like you got some other kind of power distribution going on in there, maybe for something else. Well, with the Anderson power poles on it as well. Well, you did a really good job with that. That's nice.
Well, thank you. Yeah, I really wanted to make something to house the battery because I like to be outside. And one year I was outside and all I had was the battery and it started raining. So at least this protects everything. And then I also, like I said, I put this in because last year I was actually without power for 11 days.
That's a long time.
And I was able to keep all of my devices charged and use that. So, and I could actually run a fan. I ran a small light with it. So I was good to go.
Well, I see you have some lettering on the side of the box, so that must have something to do with what you've got hooked up over here or what you're doing?
Yep, that's my call sign. It's from the FCC. It's kind of like on radio stations, which are more professional, but an amateur can go and get a test. And if you pass the test, the FCC gives you a call sign, and then that allows you to be able to talk around the world, which is really cool.
So do you really get to talk to people from the back of your car like you're doing?
Yep. I've talked to, I like to go out to parks and work portable. We call it portable in amateur radio, but I like to go out and talk to people around, around the country. But I also like to go camping. And so I use this, a primitive camping out in the middle of nowhere. And I've talked to people from Greece and Spain and Turkey and one time Israel. So it's a lot of fun.
What a fun hobby that is. So can you use this for something else? I mean, if you're not talking around the world or whatever, what other kind of communication would you use this for?
I like to talk just for fun, but what's really nice about amateur radio is in case of a disaster, in case your cell phone doesn't work, in case internet doesn't work. One time my daughter was in Hawaii and it was when they thought the missile was going to hit Hawaii. The whole grid went out. She couldn't get a phone call to me. So I've always told her if she can't get a phone call to me, she knows where to find ham radio operators so you can get messages to loved ones. I know they've used it, in hurricane areas when things have gone out. So at least you can talk to someone and get a message out that you're still there, because if you can't do it on the phone and you don't have the internet, it will work.
so you can pass messages in emergency situations to your loved ones, even if you're not there. And the phone
Right,
knows that.
right.
That's
Yeah,
really nice.
yeah, that is.
So what kind of antennae are you using with this? I mean, you have to transmit
Interestingly
on some.
enough, you know, that I made the battery box, I also use an antenna that was made by a couple of gentlemen up in Wisconsin, in Wolf River. So this is called a Wolf River coil. So basically we call this a vertical antenna. I have also another antenna that is horizontal, but this one is easy and fun to get out right away. The coils on there have been wrapped so where I bring the collar down to, it actually tunes the frequency that I'm on.
Oh, that's very interesting. This looks pretty simple to set up, so it
Very,
doesn't take a lot of hard work to get this
very,
going.
yeah, very simple. It packs up in a bag, and I can get out here and I can set it up real quick. I've set it up on picnic tables. I've set it up at campsites. I've been to so many different parks around the Midwest, and it works out really good.
And it looks like you can travel pretty light here with your little portable bag you got here with some goodies and stuff in there for probably maybe different situations and such.
Yep, sure can. I travel with this, but I usually can get out and get my box and my solar panels set up in about 10-15 minutes, depending on the location.
Tell us a little bit about your radio you're using here.
I have like a portable type radio. It's called a Yaesu 891. It's for high frequency use. It's used for the higher frequency more than something like, have you seen people with like like walkie-talkies? This is more for talking on higher frequencies.
Very
So,
interesting. Well, I thank you for your time today to take away from some of your fun, but I certainly learned a lot. I'm going to have to look into this.
Oh yeah, I know. Like, if I tune this up, I wonder if we can hear something here. So we have somebody talking. I'm not sure right now where this gentleman is at, but not sure, and he's talking to someone else that I might not be able to hear because people are all around the country. So it just depends on the radio, the way the antenna wave will travel across the country. Sometimes somebody might be in California and the radio wave will travel to Pennsylvania. But sometimes somebody in California, the radio wave can travel to Colorado.
Sounds like a lot to learn and a lot to experiment with. Well, thank you very much.
You're welcome.
And you have a good day. So
so you can look it up, and like I said, the battery and everything else, it's all doable, and you can make your own thing.
Thank you very much. It sounds like something I'm going to look into. Enjoy your day.
Thank you. From KD9 FMJ.
Well, sooner or later, maybe I'll get a call sign and I'll give it a whirl.
Okay, sounds good. I hope so. Hope to
you.
hear you on the airwaves soon.
Okay.
Okay. You have a good day.
You too. Wow, that was very interesting. I might have to check into that.
Thank you. That was very informative. And now I think it's time to turn our sight skyward to see some out of the world things that amateurs can do. We'll start with balloons. The really popular, having a lot of what they call near space balloon projects in STEM and other venues. These are basically radio payloads and attached to a weather balloon. And they rise up to around a height of around maybe just under 100,000 feet, about 31 miles, just near the top of our atmosphere. And then because of the decreased air pressure, these balloons expand and then explode or pop. And then the payload, which is the radio equipment, the cameras, whatever else is on there, begins to fall down towards the Earth. And that's where the parachute, which is a part of the project, comes into play. On the right, you can see the tracking of this balloon on the left as it traverses through the flight that it was heading on. This particular one at the moment, that snapshot, the balloon was traveling at 34 miles an hour, and it had reached an altitude of about 28,000 feet. So because the maximum height is around 100,000, this balloon was still ascending. So how far can you go with these balloons depends upon the jet stream and whether the balloon enters directly into it. But typically a flight can last 3 or 4 hours and cover anywhere from 20 to 75 miles. So this is something where not having tracking is a hindrance to you. And amateur radio and its ability to send digital data reliably is a big plus. Okay. Hold on one moment. I kind of wonder why that slide did not come up on top of it. No matter how many times you run this through here. Okay. Back on track. So here is an example of a typical balloon flight. In the upper left-hand corner, we see the payload. That's the GPS receiver for positioning, the radio equipment, and other sensors for altitude. And the lower left, you'll see a picture that was taken by the balloon as it started ascending. And as it rose up to, ascending towards altitude, you could see the launch point, which was near the stadium track over there in the red. And then finally, when it reached the top of its limit before it came down. So it's pretty awesome. And amateur radio is can play a very crucial part in that. Now, there's another type of balloon flight that is popular, or not as popular, but it has a different objective. Instead of going up and raising cameras and taking pictures, its objective for this type of ballooning is to stay aloft as far as it can and hopefully circumvent the Earth. And that calls for a different type of balloon and a different type of amateur radio technology. Here is an example of a balloon flight and a payload that was created by a Canadian amateur radio operator. And as you can see, it's quite a bit more streamlined package. The payload with solar panels and the like, radio transmitters, weighs in somewhere in the vicinity of between 3 to 4 ounces, whereas a payload in a weather balloon could be maybe a pound or 2. And as you can see, the balloons are smaller because we need them to not expand so much and explode. Anyhow, that particular balloon that I showed you managed to circumvent the Earth. It started off in Toronto and then started making its way across the Atlantic and over towards Europe, Asia, crossing the Pacific Ocean and back into the United States, over very close to where it was launched from, and then started making a second circumnavigation and then going down somewhere in Russia. Other balloons actually have been able to do circle around the Earth multiple times, including one by a British amateur radio operator whose balloon circled the Earth 8 times over a period of 134 days. It went down in Iceland. Something that you may have heard of, because this is there's a big connection with schools, and that's the ARIS program. That's amateur radio in the International Space Station. And it's a cooperative event. It's an international organization that goes and connects schools to the International Space Station, so their students can actually go in and communicate to them and ask questions. And all of this is done via amateur radio as well. Here's an example of a live chat this one was from the Goddard Space Flight Center to the International Space Station. And they have them all over. You don't have to go to a NASA facility to do that. It's interesting when you communicate with the space station, it's moving very, very quickly. And the time that it comes in where you cannot hear them to fully being able to communicate, and then by the time they fade out, is in the order of 7 or 8 minutes. And it's pretty amazing how fast things can change. I'm going to play you a very short clip that shows you a beginning of a communication between the ISS and a school out in the East Coast. This is recorded here from my location in McHenry, using just a basic radio receiver. So you listen carefully. There'll be a lot of noise at the beginning, and then you'll begin to hear a little of the voice. And then near the end of that first segment, you'll be able to pick out the words International Space Station. Then there'll be a little more noise, which is when the other station is making their call back to the space station, International Space Station. We won't be able to hear them because I'm too far away to listen to hear that. And then by the time he comes back, everything is loud and clear. Okay. So the thing is that you don't really need a great deal of equipment or very fancy antennas to be able to communicate with the space station, or really into any of the amateur radio satellites that are currently orbiting the Earth. The photograph on the right shows what a typical setup would be for perhaps someone that's making contacts regularly through the satellite voice contacts, because it needs a little more directivity. You need to be able to point the antenna to the station. But it's very lightweight, and it's be able to be held in your hand easily. But it's also possible to actually make communications, making contacts to the amateur, using amateur radio, using just a portable handheld unit here. And here's an example of a message that one of our local amateurs, Eric, made with the International Space Station using what they call APRS mode. That's a digital system, sort of like a texting application. I mentioned before, amateurs have had satellites for many years, probably going back to the early 1960s. But they were really hard to get launched because of the cost and how big they were and things like that. But there's a concept of a nanosatellite or a CubeSat, which really made things, it was really a game changer because they were a lot smaller. They could be bundled together. For example, a SpaceX Falcon rocket could possibly take 60 of these things up to the space station for launching. So to give you a little bit of an idea, there's Joanne, another one of our local amateurs, with a engineering prototype of one of our amateur radio satellites. And I have another picture of her on the right to kind of give you a little better idea of just how small they are. So once these CubeSats are transported to the International Space Station, they need to be launched. And it's done by using a deployer, which is shown in the upper left-hand corner. And then they are launched out, sort of like expelled out from the International Space Station, and are then put into orbit. And then they circle the Earth just like the International Space Station does, in the altitude of approximately 260, 300 miles, and are able to be used by amateurs around the world throughout the day. So, typically there's more than one amateur radio operator on the International Space Station at any one time, because they want to be there to be able to contact the schools. But it's not unusual to actually catch one of those radio amateurs, crew members, that are wanting to make some contacts on their off time. So it's kind of surprising. You turn your radio on there and you can talk to the International Space Station. And yesterday we had a crew come back, as you may know, one of the flight engineers, Kate, she's an amateur radio operator, and another amateur radio operator, Shannon Walker, is now is acting in the commander role of the ISS. So there you have it. We've gone through very quickly, covering a couple of aspects of amateur radio, there are many, many, many more to do and explore. It's an endless hobby that is enjoyable for all. So with that, I will turn it over for any questions and answers that people may have. And thank you for listening.
Hey, Ralph.
Ralph? David, you have a comment to share?
Yeah, I would just like to try to do a little wrap up here. I'll turn my video on so you guys can see who I am here. Like Ralph said, it's really hard to cover everything about ham radio in an hour. So, it's hard for us to do it justice. But I just wanted to say, if you want to know more about it, I would encourage you to find a local ham club. There's lots of ham clubs. And, people always say, well, why do you need ham radio? Because we got cell phones. We can get on a phone and talk to Bulgaria. We don't need to throw a wire up to the tree. Well, part of the fun is, I think, doing it. And I kind of use the example of fishing. So if you fish with a depth finder, you're going to see a fish. And chances are you're going to grab it. But with ham radio, you never know what you're going to get. And it's a lot of fun just to get out there and try and find out what you can do. Also, I don't know the age of the people that are on here, but if there's some young folks on here, I'm almost 60. And I got started in ham radio when I was 16 years old. And I tell you, it has really opened up a lot of doors in my career. Because you learn about electronics, you learn about radio frequencies, and it's not all just about computers. Computers are great, but it's nice to learn about radio frequencies and electronics and how they work together with computers and everything else that's out there. Because we're always trying to expand technology and coming up with great new things. And then, lastly, in an age where we're kind of thinking hunkered down, especially now with COVID, it's really a great way to meet people and have social interactions. The friends I've got in ham radio I've had since I was 16. They're just great, solid people. And, and then lastly, I'll just say, I think I'll admit shamelessly, I'm a geek. I was kind of got a little picked on, I guess, for that in high school. But right now you look, the geeks are kind of having a good time and they're living a pretty good life. and I'm not, impugning sports or those activities. Those are great too. I think it's good to have a good blend of everything. But if you're a techie, be proud of it, and grow with it because it's a wonderful thing.
Yeah, thank you for adding that, David. The age limit, we got started, I first obtained my license when I was 15, but I thought I was kind of a youngster at the time there. But really nowadays, the hobby is really open to everybody. And there's been, I think the youngest person that I know of that has gotten their license, even though I got mine when I was 15, has been 5 years old. And many, many young people have actually not only gotten their license, but have become very proficient amateur radio operators, contributing and having loads of fun there. So yes, this definitely is not a hobby for solely restricted to groundhogs.
I'm not actually seeing any questions kind of coming up here. So I just figured I would jump on, for the gals in the group. So I came into this later because when I was growing up, there wasn't a whole lot of things like this for girls. So I'm actually having a ball, making things. I learned how to solder in, late in life, and have made really interesting Christmas trees when I'm soldering and putting it together, and they're blinking and everything. So I'm having a real good time learning how to do a lot of this stuff. And as you can see, that battery box that I did, you guys would probably laugh if you're all makers and you're watching this. I actually had to use a hole saw on a bleach bottle to practice. So you can definitely start late in life or early in life, which there's a lot of things for girls to do now or women to do. So it's a lot of fun. It doesn't mean that you have to be sitting in a dark basement in a ham shack. And like I said, that battery that I made kept me alive last year when we had that derecho. I never could have kept my cell phone charged up with 11 days without anything. And
and it was hot in August, so I was running a fan off of it, and I had a light, so I didn't have to worry. So that's kind of an interesting aspect of the building as well. So if anybody has any questions, just ask us. We're ready to try not to blow your mind and keep it as simple as possible, because ham radio is, as you could see, was a little detailed from some of the presentations.
So as Jen said, throughout the day, if anybody has questions, go ahead and click on the Q&A box and type in anything you'd like to know from our presenters. I do want to take this moment to, really thank Ralph and Dan and David and Jen for sharing their expertise with us this morning, as well as those fun videos that they put together with some of the other folks from the McHenry group. I think you really broadened my perspective on what ham radio could all be about, and I'm sure that was the same for some of our other viewers here today. And kind of to echo Jen's sentiments, making, is something you can jump into at any point in time in your life. It can be from the very practical of something that you need and want, or it could just be something cool that you've always wanted to do. And so we're hoping that throughout the workshops, I know a lot of this afternoon's presentations are going to be workshop related, that you get your hands dirty and have some fun making. So once again, I'd just like to thank the folks from McHenry for joining us. And I think, Ralph, you are actually up for a second presentation. You're going to be sharing with us some citizen scientist perspective.
I am indeed, and welcome back. Give me just a moment here to switch gears. Go back to my station and slide deck. Definitely see what's happening here. Now, regardless of how many times you practice and test this stuff here, always something comes up. Okay. All right, I think I'm ready to begin. Good morning, everybody, and I want to have a special shout out to all you citizen scientists, and more importantly, for all you potential and future citizen science that are out there listening to us today. I'm going to be talking a little bit about what citizen science is and some of the things that I have done, and show you a few of my projects and a couple of things that I think you might find interesting. I would certainly hope so. To begin with, I will introduce and tell you that I will fess up to it. I am a curious person, and I love science, and love science is probably an understatement. I remember as a 10-year-old wanting to be a nuclear physicist. I was really interested in atomic energy, and that interest in science has kept with me throughout my entire lifetime. And I guess that makes me a lifelong learner, which is also not another bad thing to be. I think that having a curiosity about things and how they work is not only important, but really helpful to us. We use a lot of technology in our lives, and it helps to know and understand a little bit about not only how that works, but also just how our world works. And citizen science is a really good way to do that. So what is citizen science? Well, my favorite way of looking at it is called people-powered science. And by that, I mean scientific research or observations and crowdsourcing of that data. So I will be making some observations about a topic, but being able to share that and having that data open to other people to use and to learn and to analyze is really a major resource of being able to really accelerate the development of understanding. So this is particularly important for capturing rare or infrequent events. For example, the total eclipse that we had here in our United States recently, and another one that's coming up in a couple of years. there's a, let's see, where did I do this here? I participated in that by using this Raspberry Pi, which is and it's equipped with a little bit of electronics. And this acted as a radio transmitter, an amateur radio transmitter. And I was able to send signals that were received all around by other people, and we could tell what effect, if any, the eclipse had. Well, if that only happens every whatever years, it's difficult. Another really good example is the 17-year cicada event that is going to be upon us pretty soon, I think later this month. That provides another opportunity for really anybody to be able to go and make observations, sit down there and record when did I first hear them, when is the sound the loudest, use estimation principles to Fermi estimations to be able to figure out, well, how many cicadas are sitting there in my backyard. So all of this stuff adds to our body of knowledge. Now, as I alluded to, you can work alone in a case of perhaps what I just said there with the cicadas, or you could participate in a larger, more formalized project where you would be working with either other citizen scientists or citizen scientists as yourself in hand with professional science, doing really important research work. So if you're curious or you want to, if you want to have a better understanding of the world around, this might be a really good, this might be a really good thing to take up. Here is a slide. This is a little old one. This is from 2015. But this lists a lot of the different categories where citizen science is being employed. As you can see, there's a lot of activity in the biology area, the vast majority of it back in 2015. But there's also other areas like environmental issues and medical, especially with COVID pandemic. Crowdsourcing of data has been instrumental there as well. So just as there are all kinds of makers, people that like to do electronics, crafts, musicians, artists, vintners, there are also different kinds of scientists. And if your job isn't a professional science, if you don't do science all day long, then you are a citizen scientist. So what is a citizen science? Well, I guess the obvious answer is a citizen who does science, but that would have really encountered cringes from my English teacher. So I'm going to have to come up with a little bit better definition for that. I think it's a person who has got a curiosity and an understanding or a willingness to understand a little bit more about the world. And as I said, you do not have to be a professional. You do not have to have a degree in whatever field you're studying. And anyone, and I mean anyone of any age, can go and help and be part of this science movement. So why would you want to do that? Why would you want to become, be a part of this citizen scientist? Well, it is a great way to learn more about the world, or just learning how to do research, which could actually come in handy in other areas of your life as well, because of the methodology and the thinking and the observation that is used in that. It also gives you an opportunity to partner with scientists because they need your help. They are limited resources, and they can use all of the data and help they can to be able to gather their work. And I think you get a feeling of satisfaction that your efforts can make a difference. Somebody asked me once, do I need fancy equipment to be doing this? And I go, well, no, not necessarily. A lot of projects just involve yourself, your eyes, observing, noting down. So maybe a pen and a pencil and your eyes. Binoculars, telescopes, microscopes are often useful. I've got a one that I use here. I originally got it for doing my, let me see if I can show this here, doing my amateur radio construction projects because they're small. But this is an example of an inexpensive microscope which is able to magnify hundreds of times and store the data. There's an SD card, a memory card in here, and I can take pictures or I can take videos of, let's say, specimens I might find out in the wild, or boards or anything along those lines to help make things a little easier. They have other ones too that computers can plug directly into. This one, I didn't need that because I just usually I use this mostly at home. So how does citizen science work? That's a good question. And I think probably doing an example would be the best case. So this is a not trivial. This was a kind of a question that was burning in our minds a few months back, and we decided that citizen science would be the way to tackle this. Okay, so when any kind of citizen science project that you would do, and whether that is a formal project where you're working with a team of people, or just yourself that's doing the work, it's helpful to start out with a flow. And often this begins with what always begins with a question, a topic, or an objective. So, for example, in the case I'm about to go through here, there was a gentleman that was visiting the area from Texas, and he would often complain, or not often, he would often state that it's hard to park his F-150 here because the parking places in Illinois are so small, and he's from Texas. So, the question that was asked, well, what state has wider parking places? Illinois, Texas. If you would form that in the way of a hypothesis, you would say, well, hey, Texas is a big state, therefore parking spaces are bigger. Or you can have an objective. So that objective might be to gather the information to evaluate that not only if parking places are wide enough, but if there's areas for improvement for accessibility. Once you have that, then you need to go and establish a set of rules, or what we call a protocol. And a protocol is just an agreed upon procedure and way of doing things. And it's really important because everybody needs to be on the same page as far as the researchers that are collecting data. You wouldn't want to get a bunch of people making measurements in inches and and then get some of the team members making measurements based on the width of their hands. So when you do that, you're kind of you're setting the rules for the engagement. So you want to agree on your measurement units. For our experiment here, we wanted to be sure we had a wide variety of areas. So we chose urban areas, suburban, and rural. And in each of those areas, we went both for street parking, parking in big box stores like Walmart and Home Depot, and even going to stadiums, because they could have a lot more cars in them. Maybe those where the parking places were smaller. And you want to take the measurements in each location. So that's basically setting up the rules of the protocol. And then we set out and we went out collecting data using those rules. After we did that, we reported them and analyzed it, and then we were able to draw inferences. Those are conclusions that are based on the evidence that was provided. And after doing all of that, we have found that in Illinois, the average parking space width is 109 inches, and Texas is 108 inches. So this is only a single study, and it's not been peer reviewed yet, but I would think that Illinois comes out as a clear winner in this case. So that is kind of a way that scientists can go in and create experiments that are repeatable and are consistent. I'm going to take some time now and go and share with you some of my project that I've been involved in. I'm sorry, too many windows open at one time here. And then we'll use the rest of our time to do that. So my area of interest, one of my areas of interest is in environmental monitoring. So I am interested in the environment around me, air quality, all kinds of different things. And over time, I have built up my stations from different variations and iterations, adding different capabilities. So right now, this is what my station consists of. I have a weather. I have most all the common weather related data that we can acquire. I also do air quality, which is based now on CO2 and ozone and particulate matter. Those are little pieces of particulate that are floating around in the air. Also have background radiation, which has an interesting story, as well as infrasonic. That's very, very low frequency sounds like you would hear from perhaps a tornado or other events. This is an area of interest that I'm still looking into. And also monitor power fluctuations and seismic activity in soil characteristics. There's quite a bit there, but it all didn't happen at once, and we just built it up over the years. This is my current setup, or part of my current setup. On the right is the most of the weather gathering and air quality sensors. You'll see on the pole above my head there, the one at the top is a commercial weather station from Ambient Weather, and I've recently added a few months back a new weather station from Tempest or Weather Flow, which is really interesting because it got back to my roots of innovative sensors. This uses ultrasonic ultrasonic sound waves to detect wind and direction, wind speed and direction. Whereas my older one uses a traditional vane spinner and pump, which, believe me, is a pain in the neck when it freezes up in the middle of the day. Over here, towards the little yellow hook, the little white hook there, that's my air quality sampler. The sensor box is inside of the base of the unit, and there's a small fan that draws a very, very low volume of air up through the intake chamber so that we can get fresh air samples. To the left is my Geiger counter that I use for background radiation. This is augmented, or not augmented, but it transmits its data to my data collection center using an ESP32 board, a tiny micro processor. It's about a $2 or $3 board that has Wi-Fi capability. So that is all wireless. The object to the left is a raspberry shake, and I will be talking about that in more depth in a little bit. This monitors, it's a very, very sensitive instrument, and it's designed for detecting earth, movements in the earth, vibrations and motions. The device on the bottom is my Raspberry Boom, which is my infrasonic for my very, very low frequency sound board. I'm not going to dwell on this a whole lot because weather stations are pretty much a commodity and very well known. But I did want to just show this slide to kind of illustrate the progression of what I did. My first one was a single board device using a microchip microchip, basically old school back in the day. But what was interesting about that, it used an ultrasonic wind sensor, which worked really well until a couple of years into the project. The sensors just gave out on me because they weren't functioning. So I went from that generation to what was my final weather station electronics until I went to the commercial units. And these are something that I put together as well. This one is using an Arduino. This is an Arduino Pro Mini, and then it transmits to my base station using 2.4 gigahertz Wi-Fi, which did not turn out very well, as I learned, because whenever my son would go in and, well, whenever anybody would go in and put something in the microwave, it would interfere with the low power transmissions. So that resulted in my final version over here, which I used an Arduino and a radio combined into one. That's called an Arduino. And so that allowed me to cut the complexity and the cost down quite a bit. So what we have here is the Arduino Over here in the temperature shell, we have temperature and humidity. There is a Bosch barometric pressure sensor over here. And I was able to add in a lightning sensor to detect lightning and a ambient light and UV light sensor. So let's get back to the Raspberry Pi, and not the Raspberry Pi, the Raspberry Shake, which is based on the Raspberry Pi. This is what I can use to monitor earthquakes, or actually not even earthquakes, monitor movements in the earth. And it's a very, very sensitive instrument. This is some shots that I had. This is called a heliograph, and it displays the movement that the detector makes. I have my Raspberry Shake situated not in a vault, which is a holding ground, deep here, but I actually have mine sitting on a concrete slab in a relatively quiet area of the house. So that opens up interesting possibilities for not only picking up earthquakes, but other noise from traffic and other noise sources. This is an interesting thing. This is a heliograph from on the left from around, I think it was 2017 in September. And this disturbance right here, I believe, was the earthquake that occurred in Mount Carroll downstate, the New Madrid Fault. And that was registered quite distinctly. I can also, I've also detected earthquakes, very strong earthquakes, like in Alaska and down into Mexico in that area, and even by fluke the test in North Korea that made that shook the mountains off. The heliograph on the right is a one that was taken yesterday. So I want to show you something about citizen science and how important that it could be to research. I'm going to go over to my browser, and this is a view of my Raspberry Shake live in my home, and I can look at heliographs, which we're not going to do because we just did that. But what I can do is I'm part of the Citizen Science Project, so I transmit my motion data to them, to the Raspberry Shake Net, and that allows me to participate in citizen science by recording data. So here we are. This is a picture of the world and all of the different sensors we have, and mine is in there. I'll show you that in a little bit. But I wanted to go to earthquake view, and it's really interesting once you start monitoring seismic activity, just how many earthquakes occur in the world every day. And this is current, and the different colors. The brighter they are, the more severe the earthquakes are. For example, this red one over here was on the Galapagos Island, and it had as a magnitude 7. So I bought my Shake because I was interested in getting data from New Madrid. There's a fault line that's run through Memphis, and it's going to be interesting when that becomes more active. But also, I was interested in the fracking that was going on in the Oklahoma area. So let me go over to station view. And here is a station. I gotta wait for this to update because this is live. This is the latest station, which is in France. As I back off a little bit here, the update speed. These are all Raspberry Shake stations that are operating and transmitting their data to ShakeNet. Over here in the United States, here we are. We also have a number of units there as well. You'll notice that they are concentrated in areas of a lot of seismic activity, such as Southern California, the Pacific Northwest in Seattle area, and also, let's see if I can make this a little bigger. But also, there's also another grouping there in the area of Oklahoma where there's a lot of fracking going on, as well as in the New Madrid area. And so you can go ahead and zoom in on mine. Okay, that's better. Stop. Okay, here's me. This is my station right here. I would click on that. And right now on the left-hand side, you are actually seeing live seismic data coming from my station. And will be fed into the internet. And it's used for not only detecting earthquakes, but kind of validating earthquakes and providing additional data points so that the resolution of the earthquake data, all details of where is it located, is augmented because there's so many pictures of that being taken at the same time. Sort of like the the MRI and the CAT scans that take lots of pictures and are able to make things a lot clearer. Now I am going to see, I have to see how we're doing on time here. I want to actually share my my cell phone because there's a really good app that we can take with you. I have it set up here. I did not want to run that live because if I got a call, that would have been disruptive. Let me just take a second here. Oh, yeah, there we go. Okay. Here's a picture of my phone. Go into hobbies. There's an application called Earth, but it's actually two applications. One's called Earthquake View, and the other one is called ShakeNet. I'm going to go to Earthquake View first, and this provides a number of information that's out here on the ShakeNet, or what you'll see on ShakeNet, I'm sorry. But here we are with the earthquakes that have been detected in the area. I've got mine set up, sorted by intensity over 5 and by distance. Turn this off. Filter. Anyway. And now we have a lot more coming in here, the closest being in Oklahoma. So usually what I try to do is I go in and I'll select an event, a fairly strong earthquake or an event that I think I might be able to pick up, and then I will go ahead and select it. And when I do that, it shows the location of the earthquake and also shows in that image there what my sensor was showing at that particular time. So in this case, the data is telling me, you see the little line there, that is the P line, that is where the earthquake was expected to be detected at my location. There's another line over here, which is the secondary wave. And as you can see, since the data did not line up with either of those two marks, this was not an earthquake that I detected. Going into ShakeNet, we have a similar type of thing right here. And if you go back in and be up over here, select the New Madrid. This one gives me a graphical view of what the earthquake looked like. Because sometimes you stare at a heliograph and you see a bunch of squiggly lines, and it's really kind of meaningless, or not meaningless, but it's kind of hard to decipher what is, which is, what's relevant or not. But by the ability to visualize them in different ways, either by that energy spectrum or even by converting that energy spectrum to sound, things become a lot clearer. So let me see if this is going to work. I had some problems playing a sound in the last presentation. But here's an example of an earthquake, a part of a heliograph that was put through a program which converted to sound. Okay, I think that Oops.
Hey, Ralph,
Yeah.
we're coming up on time for the next presenter.
Absolutely.
just-
I was just, yeah, no problem. That was actually the last thing that I wanted to, report. And if I like one more point, we can wrap that up. That even though I'm monitoring seismic activity, because of these sensors that are out here, we started getting data that provides some really interesting information about how our lifestyle patterns are changed. For example, what changed when we went into COVID lockdown? And I'm going to have I have some links up on the project site later today that will allow users to see that. So sometimes the data that you're doing in citizen scientists may have been designed to answer a specific question, but you will find that's able to use elsewhere there. So with that, thank you.
And likewise, Ralph, if you have any good links that you want me to add to your profile that we have set up on our website, just go ahead and email those to me and I'll make sure to post those to share with our audience.
Great, it would be my pleasure. Thank you.
And thank you once again for joining us this morning for 2 presentations. And I think really opening up our eyes on some different ways to look at the world around us.
Well, thank you. Good day.
Okay. And with that, I believe we have Sam here joining us. She's a CLC engineering intern, and she's going to be sharing with us how to make a glider. So this is one of the projects. If you happen to pick up a maker kit from campus, this is one of the projects that was within that bag. If not, certainly I believe most of these items you probably have around your house. So you can go ahead and make yourself a glider today.
Hello everyone, my name is Samantha Campos. I'm an engineering intern here at CLC, and today I'm going to be showing you how to make a simple air glider using items found around your home. I'll be creating my glider using circular shapes, but feel free to use any other shapes that you want to create, such as a triangle or a square or an octagon, anything really that you prefer. So let's begin. Okay. So you will need paper strips, which are 8 inches in length and 1 inch width, paper straws, tape, and scissors. If you don't have a Pitsco kit, you can take regular paper and cut out some strips using the dimensions I provided. All right, so after you gathered all your supplies, you can now move on to step 1. So you take a strip, fold it in half, and cut it. Now you're left with 2 4-inch strips. Next, you're going to take one of the 4-inch strips and form it into your desired shape. In this case, I formed it into a circle, and you can tape it. Here's a helpful tip. I pre-cut 4 pieces of tape and set them aside as it can be tricky to cut and tape at the same time. Next, you're going to take a full strip of paper and form it into your desired shape. Once again, I chose to form it into a circle. And then you're going to take 1 paper straw and tape one end of it onto the inner portion of the smaller circle first. Next, you're going to take that same straw and tape the larger shape onto the other side. And congratulations, you have made your first air glider and you're ready to fly. Next, you'll see a video of my glider in action. So let's see how far you guys can fly. All right. So with that, if we had any questions regarding how to make this, you can put it in the Q&A. Other than that, yeah, that's how I made my glider.
So it doesn't look like we have any Q&A quite yet. I noticed when you guys were launching your glider, I mean, you had the advantage of having a second story to launch it off of. Did you find, compared to like a regular paper airplane, that you need to throw these a little bit harder or softer than what we're used to?
Definitely you have to throw it a bit harder because it is kind of heavier than a paper plane. And definitely the height definitely helped with the flying and the gliding. So if you can, I don't know, I'm not saying climb a tree or anything, but if you can like launch it off, the top of your stairs or something, that'd be great.
Okay, thanks for that suggestion. Are there any other projects besides gliders, as far as projects you've been working on yourself, anything you'd like to share with us, different types of making that you like to do?
Yeah, I work with like I know I entered the bridge building contest for the Maker Faire. So yeah, that was fun to construct my own bridge. I want to see how it turns out later. I've also been working with Arduino and yeah, creating my own projects on Make projects and things like that.
Okay, so as Sam referenced, we do have a balsa wood bridge competition that's happening later this afternoon. I think that's at 2:20. On track 2, they're going to be using a tensile compression machine to actually compress the bridges and see which ones stand up. They'll be comparing both the weight of the bridge and the strength. So if you tried to make yours stronger by using a lot of wood or a lot of glue, it's going to count against you a little bit as far as the weight. So it's kind of that strength to weight ratio that they're going to be looking for. And then as well, right after that is going to be the paper rocket launching. And so if any of you have had an opportunity to check that out at Make Projects, it shows you step by step how to make the paper rockets. And then you can swing by campus around, I think starting anytime after 1:30 to drop it off, but around 2:30 is when they're going to be launching those rockets into the air, and you'll be able to see just how far in the air you can get yours to fly. And I believe Sam actually helped out with some of that and made a few test rockets when we were out in the parking lot the other day. So once again, Sam, thank you for stopping by and sharing that glider experiment with us. I'm hoping some folks at home are having the opportunity to create a glider of their own. And that's really one of the things that I think we looked at as we switched from an in-person Maker Faire event to something that was going to be virtual, is how can we get everyone involved? How can we get that experience of making? If any of you have been fortunate enough to go to Maker Fairs in the community in the past, I know I've been to some in Milwaukee and other locations, and Sheboygan typically has one as well, thinking of ones that are relatively close to us. And one of the really fascinating parts of a Maker Faire is not only do we get to see kind of a peek into these other people's spaces and ideas of projects they've been working on, but so often there are make and take projects where you can walk up to a table and have those hands-on experiences, learn a little bit about some new technology, or even just try something that maybe you can't find time to do in a normal day. And with that in mind, we tried to create some virtual experiences leading up to this event for the community to get involved in. And so a few of those that we had happening back in the fall, or sorry, in the spring, is we talked a little bit about creating a logo. So we were asked by Make to consider what represents us as a county. And I thought the best way to find that out was to throw it out to the community itself. So for our logo contest, we had people give us their ideas. We had a 3rd to 5th grade group, a 6 to 8, a 9 to 12, a college, and then a community group. And so you can see the 5 winners shown here on the screen of the different things that people think of when they think of Lake County. So obviously Makey, being part of Maker Faire, shows up in many of them, but you also see some ideas of, spring and sunshine with some flowers and butterflies there. Certainly Great America gets its spotlight. I think we've got a roller coaster as well as the tower. The one on the top right kind of shows our heritage as well. You see where we've got our corn stalks and our barns, certainly the roots of Lake County, And then more of a high-tech building to the right, showing some of the various things that we have happening here as far as construction and as far as businesses that have really grown up in Lake County. And then finally, I really like that kind of homage to the lake itself with the waves in the bottom. So if you head over to Make Projects, you can see all the entries, but I just wanted to share with you these winners and get you thinking, you know, what do you think of when you think about Lake County? We'll be using some ideas from these winners and certainly, you know, looking for more ideas in the community. As we start planning next year's event, they've asked us to make sure that we have a logo to have front and center. And so we'll be continuing to do that development. Speaking of next year, right now, we are looking at April 9th to be when we come back and do this again. And hopefully that will be an in-person event so that we can get together and have some of these hands-on experiences. The other event that we threw out to the community was a 3D modeling contest. If you saw some of the promotions that we were doing beforehand, one project we've been working on in the Baxter Innovation Lab is taking the board game Catan and turning those small 3-inch tiles into something that is 17 inches wide. And we were trying to envision what could those different tiles look like. And so the field tile, which earns you sheep cards, we put out to the community and said, what could this look like? And so here are the 2 winners from the high school competition. And the one on the left side represents kind of a traditional view of the field and sheep, where the one on the right side was given the Creativity Award, just based on the nuanced way that they represent sort of the farm fields, but then they also show the barn and a variety of different really kind of cool architectural items. Whereas the one on the left was given the Best Match Award. The latest contest, which just wrapped up last night, was the Make-a-thon. When we launched the Make-a-thon on April 1st, individuals were given a kit of electronics. It had an Arduino, a couple of motors, 3 or 4 sensors. And they were given a specific challenge to level up their study space. Certainly in the last year or so, we've all found ourselves sitting more or less in the same place. A lot of our students kind of displaced from their classrooms and into their homes. And we asked them to think about how could you take your space to the next level, whether it was improving kind of the airflow, coming up with a study buddy, or maybe something that actually reminds you to take breaks or gives you rewards that interacts with you during your day. And so these awards are being announced right now. So we've got the most aesthetically pleasing, where we've got this really nice fan put into this Lego frame, as well as this design down here to the right, where they've created a box where it has light indicators for whether the room is hot or cold, and then also an ultrasonic sensor so that it knows when you're sitting there and can turn the fan on for you. We've got the entrepreneurship experts, which created designs that we think are just ready as they are for someone to want to purchase. We have this Screaminator, which will elicit sounds when you've been at your desk for too long. And then we also have the Study Buddy that not only doubles as a good-looking fellow, but will sense when you've been there a certain amount of time and offers candy rewards. And the last one here on the right is super engineered, because not only did they use the items that we gave them in the kit, but they added a Raspberry Pi and several other elements to create a design that was above and beyond what we were expecting. And so I would encourage you to go to the Make Projects website and explore these designs. And you can see all the details as well as the videos that these individuals put together to share their projects. And so I think we have a couple more minutes before the Deerfield Library is going to be joining us. I'm going to go ahead and share one or two of those videos with you.
Lake County Maker Faire 2021. Just step away. Monitor your time at your desk and trigger reminders to take breaks.
Do you ever notice yourself getting distracted? Is this starting to become a problem for you? Well, now there's a way to stop that.
Introducing Demonoway. Demonoway is constructed of a SparkFun Redboard, a few motors, an ultrasonic sensor, a Raspberry Pi Model 3B Plus, and many more. Demonoway is designed to monitor your time usage on a computer and give you reminders if you're spending too much time on it. The way it works is that an ultrasonic sensor monitors and records data down on how much time your hand is on your mouse.
If the timer exceeds 30 minutes, the Monoway will go into an alarm mode, which triggers the motor to drive in a random direction. When the alarm mode is triggered, the Raspberry Pi will also activate Spotify to run off a Bluetooth speaker.
To disable alarm mode, you must put the mouse towards the ultrasonic sensor and keep it there for 45 minutes. If the mouse is moved before then, alarm mode will be activated for 2 minutes and nothing can stop the robot, even putting the mouse back. After the 2 minutes are up, alarm mode will be then activated and you must disable it. Towards the end of your 45-minute break, the Monoway will return to its original position using a Raspberry Pi and magnets, waiting for you to use it again.
The whole project is powered by a Raspberry Pi and a power bank, so you do not have to ever worry about turning it on or off. Charging is quite simple. All you have to do is plug in a standard USB cable and you're good.
This project was created for the Maker Faire 2021 by Luke
and Simon Sikora. We are currently working on designing a version 2, which will have more features and more capabilities.
Thank you. Lake County Maker Faire 2020.
So I think we have time. Let's go ahead and take a look at the Screaminator.
The Screaminator. With more people working at home with the pandemic, knowing when to work and to take breaks is essential. The Pomodoro technique is one way to manage time while working. This technique involves working for 25 minutes with 5-minute breaks. Our device employs the Pomodoro technique by alerting the user to take a break using its speaker. During the break, the device senses if the user has left their desk. If they haven't and are still working, the device will scream and flash its lights.
Okay, so when the 25-minute work period or the 5-minute break is over, the blocks will alert you that it's time to change by playing a little song. And just for demonstration purposes, here's what the song would sound like. It would just be the speaker playing Mary Had a Little Lamb, and that would be your alert to get up and take a break or to come back to work. During the 5-minute break period, the Screaminator will test if the person is at their desk using an ultrasonic distance sensor, and if the person returns, the speaker will sound and the LEDs on top of the box will flash.
Yes, I'm ready to get some work done. Dang it.
Like you can hear when my co-host sat down, the box sounded and the LEDs flashed.
So as I mentioned, there's a variety of different projects in Make Projects. You can watch the videos for the snack time dispenser, the automatic fan, and several others that are present there. And so I would encourage you to take a look at all of those. It looks now like we've got Zach and Ethel here to join us from the Deerfield Library. They're going to be giving us kind of an inside peek as to what their facility looks like and some different opportunities available to the community within their facility. So Zach and Ethel, welcome to the Maker Faire.
Yeah. Can you hear us?
We sure can.
Awesome. Great. So welcome to the Deerfield Library Makerspace. It's kind of been a long time coming for us to show this off to people, but I guess it would be good to start off with a little bit of history. So the Makerspace officially opened in November of 2019, and we had a pretty solid few months of activity, people coming in, doing projects, before we obviously had to shut down. And while we managed to keep a continuous stream of activity through virtual appointments and things of the such, while we were closed, we certainly weren't seeing the space reach its full potential. Fortunately, we have just started reintroducing in-person appointments in a very limited capacity, but we are seeing people slowly start coming back into the space, which is really good. So we're really looking forward to seeing some more activity coming through here, because this was a big project for us, and everybody was really excited to see this space get put in here. And we really want to see it being used to its full capacity. So yeah, I'm just going to start with some different pieces of equipment. We have sewing machines here, which are relatively self-explanatory. You can sew with them. Obviously, if you're using this, you probably know what you're going to be doing with it. But like everything else here, if you do have questions, if you don't know how to use it, you need help setting anything up, we're always here to help you. Both me and Ethel here know how to use all the equipment. So any trouble, any hindrances you might have, we're here to help you work through those. So sewing machine, like I said, pretty self-explanatory. Over here, we have two embroidery machines. This was the first embroidery machine that we got. It's pretty good. However, once we started noticing that embroidery was a very popular service for most people coming in here for the makerspace, we realized that we wanted to upgrade. So we also got this slightly better Janome embroidery machine. So effectively doubling our capacity of embroidery projects that we can do. And embroidery is a very, very popular thing in here. We see a lot of people coming in to do embroidery projects. And fortunately, they're very easy to use. And one thing that we push for here in the makerspace, above all else, is open source. So say you have something you want to embroider, say you have a design, we found great ways to be able to take digital images, digital creations, and convert those into embroiderable files, because that process can be a little bit difficult. There are proprietary softwares that you can use to make embroidery files. The only problem with that is you have to pay for these softwares. However, we did find a way to use Inkscape, which is a free vector design software comparable to Adobe Illustrator, that has a plugin to create embroidery files. It's a bit more complicated. There are a few more steps to creating the files versus a one-click digitizer. The upside to that, however, is that we can tell patrons, anybody coming in here, that that software is 100% available to them at absolutely no cost. So if they want to go home and create a design, they can absolutely do that. We can show them how to create their own embroidery files without having to spend a dime. So these things are really great. They're very popular here, and we really would love to see even more people coming in and creating some awesome things here. Next up, we have the vinyl cutter. It is a Silhouette Cameo 3. And while it is called a vinyl cutter, there are many other things that it is capable of cutting. This thing can do paper, cardstock, vinyl, fabric. We have the fabric blade right here. Switching out blades is very easy, fortunately. And this is also Bluetooth enabled. So as long as you have any computer within a proximity of this, you can send files to here to easily get cut. And this is really great for just making simple things like stickers that you want to put on a water bottle, making decals for your wall, anything of that sort. One other thing that people are very interested in, however, is heat transfer vinyl, which is a bit different from regular vinyl. So regular vinyl feels a bit more papery. Heat transfer vinyl has a bit of a different consistency to it, but the really cool thing about it is that you can use it to transfer to fabrics. So if you want to take a look right here, can you see the t-shirt? So this t-shirt was made entirely with heat transfer vinyl. And it's a very simple process. Obviously, we're here to show you how to do it. But we have all the tools necessary. We have a small iron and an ironing board for the transferring of the heat transfer vinyl. But yeah, this thing is really great, many different uses. And as always, we love seeing people come in and make creative use of it. So as we go on, we have a very large supply of vinyl for the vinyl cutter. Many different colors to choose from, so you'll never be at a loss of any color you want to choose from, any type of vinyl you want to choose from when you are cutting. This paper castle that we have here was made entirely on the Cameo. So you can do quite a lot of different things with it. All it takes is your imagination. So as we move on, we have our electronic station here. To push that these pieces of equipment we have are incredibly useful. So we have a full Dremel station. Dremels are very multi-purpose tools that you can use for many different things, including wood carving, polishing, many different things. It has many different attachments, assortments that you can use for touching up projects that you might be doing on the laser, on the embroidery machine, anything of that sort, as well as a relatively high quality soldering station. And of course, soldering is great for electronics, stained glass, wood burning. There's many different things you can do with the soldering iron. So we really encourage people to, you know, get creative, think of ways they could also use this equipment, because a lot of this stuff is a great complement to the other stuff you might be doing in here. But yeah, we are really trying to push the visibility of this because a lot of people tend to not be aware that we have this. However, it is really high quality stuff. And we really want people to know that this is here and accessible for them. As we move on, we get to our 3D printing area. So we recently just got these. So this is a resin 3D printer. I'm sure some people are pretty familiar with how 3D printing works. In terms of a regular 3D printer like this one here, which is an FDM printer, it goes layer by layer using plastic filament. The cool thing about a resin printer is it uses liquid resin and UV light to extract models from a vat of resin. And the detail you can get on a resin printer is much, much more intricate than you can with a regular 3D printer. So we're very much looking forward to what we can get done with this. The process of doing a resin 3D print is a bit more complicated. That's why we also have this equipment right here. It's a curing station and washing station. So once you complete a resin print on here, you want to wash the print in alcohol here. It also uses UV light to cure the model, but it's kind of all in one and here for people to use if they want. And we're really looking forward to seeing what we can do with it. As we move on, we also have from TerraCycle a bin for 3D printing waste. As you know, 3D printing can produce a lot of waste material, scrap with supports, things of that sort. And it can really start taking up a lot of space, and you don't want to end up throwing all that stuff away. So this is a really great way to make sure that we're being environmentally conscious about the waste material we are producing with 3D printers, because that's very inevitable with 3D printers, is that you're going to have waste filament. So we're very happy we have this thing. It's a very reputable corporation that this box comes from. Over here, we have our regular 3D printer. A lot more people are familiar with this kind of printer. It's FDM. It's the classic layer by layer style 3D printer. This has been going strong ever since before we opened the makerspace. We have an online form where you can submit files to us for you to print. We have more than one 3D printer. This is the one we currently have here in the space. We also have a larger scale 3D printer for doing large scale prints. We're currently working on repairing that one as it was having some issues. But we are hoping to have it back here in the space very soon. And yeah, anybody who wants to have something 3D printed, absolutely feel free to use our form and have something submitted here, because we're happy to print it for you. Over here, we have our printing stations. We have two kinds of printers. Over here, we have a photo printer, which is very good for producing high quality images from digital files. It's not used as much as some of the other equipment here. However, we like to inform people that it is still here if you want. It's great for taking digital photos and printing them out, framing them. Not much else to say for that. Photo printing is pretty self-explanatory. We have a variety of different types of paper. We have matte paper. We have glossy presentation paper for you to print from, as well as recently a selection of sticker paper that you can first print on with this printer, then bring over to the Silhouette Cameo to have cut out, in which you effectively are making your very own custom stickers. So there's a lot of different things you can do with this printer, and we really want to make people aware of just how powerful this little guy is. Over here is our large format printer. Now this thing is a lot more useful for posters, blueprints, things like that. It's a technical printer, so its aim is not quality, but more quantity. However, you can create pretty good looking stuff with it. This is one thing that we made with the large format printer. So you can make some pretty cool posters with it, even though it's not meant for quality. However, a lot of people use it for signage, posters, birthday signs, things of the sort. And we try and keep the cost relatively low, about $1 per linear foot. So most prints don't come out to be more than a couple bucks, which people tend to like. This thing is really great. And yeah, if you have any ideas for posters, signage, this is your place to go. Over here is kind of the de facto crown jewel of our makerspace. It is a ULS, Universal Laser Systems laser engraver. This was donated by the Friends of the Library, and this is by far our most popular piece of equipment. This thing can cut, engrave many, many different kinds of materials, from wood, cork, metals, acrylics. And yeah, it's very powerful, and we're here to help you create the designs that you want to make on here. We can show you a couple different kinds of things that you can make on here. So this is a good example of something that you would make with wood. And a cool technique you can do is, depending on if you coat the wood with tape or not, you can kind of get a smoky looking style for the wood. So this is what it looks like without masking off the wood before engraving. This is what it looks like when you do mask off the wood. You just kind of get crisper edges without any of that smokiness. For a lot of people, it comes down to personal preference, but you get some beautiful results on wood. You can do things like stone. Stone is another great example that produces excellent results. Cork coasters and vinyl just as well look very nice. You get incredible results with acrylic. Cork coasters, people tend to really enjoy because the contrast you get is incredible. You get these really, really nice black tones contrasting the natural cork grain. And one last thing that you can also do on the laser is glass. Glass produces very beautiful effects. And as you can see, this is cylindrical. We also have a rotary tool for the laser. So you can do flat objects, of course, with the cutting bed we currently have in there. But we also have a rotary tool, as I said, where you can do round objects such as metal coffee tumblers, wine glasses, anything you can think of that's round. You can probably engrave it. So that tends to give people a lot of different ideas. And that basically sums it up for our laser engraver. One other thing that a lot of people have interest in here is our digital media lab. This is for converting legacy type medias. So we have a lot of different equipment for converting different forms of media. We have a Wolverine here, which is used to convert 8mm film as well as Super 8 film. We have a cassette converter, so you convert cassette tapes to digital files. We have a VHS to DVD converter, so you can both convert VHS tapes to digital files if you want. You can burn it straight to a DVD if you want. But as you know, a lot of people have old VHS tapes that they're not quite sure what to do with. For a lot of people, this is the answer for turning those, precious memories from the VHS tapes into more reliable digital files that they can store on a thumb drive, cloud. or whatever other file storage type you can think of. We also have a photo scanner. This is a really impressive photo scanner. You can obviously do photos with it, but it also has various different guides. So you can do things such as color negatives, black and white negatives. You can do slides. You can do specifically sized photos. And the great thing about this is it has an auto crop feature. So say you were doing slides, you simply insert the slides into these areas right here. And then once it's put into the scanning bed, the software automatically crops each photo into a separate file. So it takes a lot of the grunt work out for you. So this is another great way to convert things like slides, which, you know, are very susceptible to water damage over the years, things of that sort. This is a great way to protect those photos, put them onto something more reliable, such as a cloud storage or a thumb drive, something that you can keep a bit more secure than slides stored in your basement. We also have a vinyl recorder if you want to record your vinyl records, as well as a camcorder for mini DV tapes. So there's many different kinds of legacy medias that you can convert here. All you need to do is make an appointment, and we're happy to show you how to do that. Our programming times currently are 90 minutes, which so far has been more than enough for most people. Obviously, for the Digital Media Lab, converting legacy media is real time. So if you have a 60-minute VHS tape, you will have to sit here for 60 minutes as it converts. However, that hasn't seemed to be too much of a problem for most people. But yeah, that is our Digital Media Lab. And yeah, just one moment. Right. And we'll have a lot of different programming over the summer. So definitely keep a lookout on our blog, our website, our Facebook. We have a lot of different social medias that we can share. But we'll definitely be keeping everybody updated about what we're doing on those social medias. And one last thing that we have to show. This is a big crowd pleaser for us. Just need to have the projector turn on real quick. So this is called an augmented reality sandbox. And the really cool thing about this is it uses a Kinect sensor from an Xbox as well as a projector to project a landscape onto this bed of sand here. Do you think you could move it a bit closer? All right, just give us one minute to reposition because it is in a bit of an awkward angle.
So while Ethel's getting you all set up, we'll give her a minute to move everything around. We had a couple of questions, and I know some of them got answered via typing, but I'm going to have you answer them verbally for the people that are watching us via YouTube.
Sure.
The first one was, who is able to access your space?
So our space is available to everyone.
Is it specifically for the patrons of your library, those folks who have your library card?
We're trying to make it available to everyone. I think as we slowly start back up, it's been offered to residents of Deerfield exclusively. However, our ultimate goal is to offer this to everyone. When we had first opened, this space was available to everybody. One limitation we did have was that only residents were free to make appointments for the makerspace. However, if there were no appointments, anybody from any district, anywhere was free to come in and use our equipment. And that's what we're aiming for as, you know, the situation slowly evolves with everything, is that we get this space open to everybody, because this is, you know, at its core, a place of learning, and we want this to be accessible to everybody. We don't want it to just be a specific group of people. So regardless if you're from Deerfield or not, feel free to inquire with us, and we can always try and make something work if you're really interested in using this space. Because like I said, we want this to be available to everyone, not just, you know, a limited capacity of people.
Okay, and then a little bit more of a specific question back to your universal laser. Do you happen to know what the wattage is of your laser?
Yeah, I can, just 1 second. So I believe it's, I don't have the specific numbers right now. But if anybody wants to know specifically, they can absolutely send us an email, and we'll be happy to provide them that information.
Okay, if we go on your library website, is there perhaps more information there as well?
Yes, any questions you might have, we have a frequently asked questions section on the Makerspace page of our website. So if you just go to the Deerfield Public Library website and go to services and go to the Makerspace tab, it will take you directly to the frequently asked questions, the services that we offer, as well as options for booking appointments, approved materials for the laser, as well as other various information that you might want to know about the Makerspace.
Okay, great. So if you're ready, I guess we'd love to see your augmented reality sandbox.
Yeah. So we like to use this thing to kind of teach AR technology. The initial intent of this was to teach the watershed effect of kind of how runoff affects landscape. But for a lot of cases, it's just fun for people to play with and kind of dip their feet into what augmented reality technology is. So as you can see, it's dynamic. As you move the sand around, the landscape changes. So you can kind of dynamically create different forms of terrain on here. It's just a really cool thing to play with. We've taken this to various different schools, and this has always been a hit with the kids there. Unfortunately, we probably won't have it available right now, as it's very hands-on. And we, of course, are trying to be as sanitary as possible in the space right now. But as things improve, we absolutely plan to reintroduce this to the space. But yeah, just kind of a sneak preview. This is one of the things that we have here to come and try out. Not a lot of people have this. It's based on, I believe, this is based on technology from UC Davis. It's open source. So we basically built this ourselves. But yeah, it's a really cool introduction to what AR technology is. in case anybody wanted to learn a bit more about that. But yeah, that's basically it for our space. All the key points. So
Okay, well, that's really cool. And I know I've seen those tables in person before, and the camera work and your lighting just didn't quite do it justice. It's a very cool thing. You're able to move the sand and then you see the map actually transform as you move it. There's a question from Olive asking, is this open now? I'm not sure if she means the table or the overall space, but are people able to make appointments at this point in time?
So yes, you can make appointments. As I said, I believe currently we are trying to offer appointments to Deerfield residents. However, if anybody is interested, we're always free to work with them and see if we can make something work. Because this is an ever-evolving situation, we are looking for ways to constantly make the makerspace more available. So even if you're not a Deerfield resident, I strongly urge you to reach out to us at our email with any questions, and we can do our best to answer them, see if we can make anything work for you.
That's great.
Our email is just makerspace@deerfieldlibrary.org. So any questions you might have for us, just send it over there and we'll be sure to answer you very promptly.
Okay, well, I really want to thank you. And I know we didn't really get to see Ethel because she's hiding behind the camera screen, but I would like to, there we go. Thank both of you for joining us this afternoon for our Maker Faire. And we certainly hope folks get the opportunity to take advantage of your space, make some things, and then when we get back together a year from now, they can bring their creations and show off their new skills.
Yeah, definitely. We look forward to it.
So thank you very much for sharing your afternoon with us.
Absolutely. Happy to share.
And so as we talk about making things, certainly I just want to remind all of you about the rocket launch. So we're doing a paper rocket launch out in the parking lot here on the CLC Grays Lake campus around 2:30 this afternoon. So if you haven't made your rocket yet, head over to Make Projects. And if you click on this video here, Rob Tordak, the other engineering faculty here at CLC, will give you a step-by-step guide on how to get your paper rocket ready for the competition. Well, not so much competition as I guess we'll say exhibition, but it should be a lot of fun. I understand it's a gorgeous sunny day out there right now, so it'll be a good opportunity to get out and see some rockets launching. So all you need for that is some paper and tape. And if you happen to have it, a 1/2-inch PVC makes a really good form to make sure it's the right size to fit on the launcher. And let's go ahead and Kurt Jackson has joined us to talk us through another workshop of creating a catapult. I think I'm a minute or two early, so if you don't mind just chatting with me for a second, Kurt, in case folks are joining us specifically at 1:10, maybe you could share with us some other types of projects that you personally like to do. So if you want to talk a little bit about CAD or 3D printing or anything else that you've done in the past for making projects.
Yeah, I like doing a lot of CAD work. I've made different type of gearboxes. That's like mechanical engineering stuff. I'm a mechanical engineering major, so that kind of stuff is really interesting to me. There's a few pieces at the lab I have, some laser engraving, some 3D prints. We have a CNC mill, which is also very nice to use. It's a relatively large format, so it's quite powerful and quite easy to make complex shapes. Trying to think of what else I've done. We have a resin printer also. It's a really fun piece of machinery to use. You should come in to the lab if you haven't already and check out some of our machinery. It's really a great place to work, and it's a really great place to enjoy engineering. So if that's something you find interesting, then drop by.
And when did you first start doing CAD work? Like, how did you get interested in that?
Oh, well, I've been doing CAD work for a long time now. I started with SketchUp, probably, I don't know, 2008, like a long time ago. So I've been, I moved to Fusion and Inventor. I've done a lot of different CAD work. Most of it's pretty similar. It's a lot of Boolean operations, which means you take shapes, you take primitives like squares, rectangles, that kind of stuff, and subtract or add them to other shapes. If you haven't dipped your toes into CAD, Fusion 360 is a really powerful and free tool for students. So take a look at it. You also have the Tinkercad, which allows you to do Arduino stuff. That's also very fun to use. I think we're getting close to the time. Do we want to do a few more questions?
Do we have any questions in general from our audience out there today? Anything about making in general, about different types of equipment that people use for making? I'm not really seeing too much of this time. As Kurt mentioned, he's one of our interns at CLC, works in our Baxter Innovation Lab. So I know we haven't really gotten much of a chance on this track to get a sneak peek. If you've been watching robotics, I believe the Skills USA team was in the lab showing off their robots. So you got to see a portion of the lab with that video. And then I think they'll be in there later this afternoon with the balsa wood competition with the bridges. And I think probably won't see a lot of the lab. I think they're going to be doing a close-up mostly of the equipment. But if you look online, the CLC Engineering Facebook page or YouTube, I think we've got some footage there as well showing about the lab.
Yeah, the bridge competition is a really fun opportunity if you guys want to try it next year, or I guess next semester even. So I guess I can get going into my catapult. Okay, so today we'll be building this catapult here. You can see it's made out of some popsicle sticks, glue, a cap, and some rubber bands. If you dropped by the lab, you could have picked up one of these kits. It's a it's a kit made by Pitsco. It has all the ingredients and all the components you need to make this catapult. If not, we're going to go over some of the parts you need to collect throughout your house. So first, you're going to need 8 popsicle sticks. They look like this, and if you have 8 of them, I'll show you how many you need. You need 8 there. That's what it looks like. You can use a few less or a few more if you don't have the right amount, but that's the recommended. You're also going to need 3 rubber bands. They used to connect the frame together and to connect the arm together. You're also going to need a bottle cap there that holds your projectile, and some glue to attach it. So while you're collecting those ingredients and those components, let's talk about how a catapult works. What physics allows you to, do this kind of amazing machinery. So there's a few components of a catapult that you need to know about. You have the frame of the catapult, which is this part here. That allows that's the frame that connects all the components. You also have the fulcrum. The fulcrum is the point that connects the lever arm, which is this piece here, to the frame. You can see the fulcrum can move as the frame is slid up and down the lever. You're also going to have the basket, which holds the projectile, which you're going to shoot, and all of the connecting pieces like the rubber bands. So we can get into the machinery and the process to build this. I have a video pre-recorded, so I'm going to play that. If there's any questions that you guys have in the chat, please feel free to ask them. I'll pause and answer any questions that are brought up. So here, this is the video of me building the catapult. We have here, these are 10 popsicle sticks. Like I said, you only need 8. 3 rubber bands. Some cap, some glue, and some aluminum foil. The aluminum foil is used as a projectile. It's what you're going to be shooting if you have the kit. Feel free to use other projectiles if you don't. The aluminum foil can be substituted with maybe some cereal or some paper. Anything you have lying around the house that you'd want to shoot, feel free to put that in your catapult and try it. So first, we're going to start by building the frame here. You're going to build the frame out of 6 popsicle sticks. So like here, you're going to see 6 popsicle sticks, and you're going to attach them with rubber bands. This can be a bit tricky. So what you're going to do is you're going to, just like you're tying up hair, you're going to put the rubber band around it and then twist it to make a figure 8 and loop it back over the pile of sticks. It can be a bit tricky to get at first, but it's not that bad once you get the hang of it. So you're going to do that to one side of the 6 sticks, kind of a little rhyme there. And then on the other side, you're going to do that. But first, you need to attach 1 stick at the bottom. This is going to build the frame, which is what we're going to attach the lever arm to. So sandwich 1 stick at that bottom, and then apply the same process to the other side. At this point, you're done building the frame of the catapult. And also, if I'm going too fast, feel free to pause and ask any questions about the building process. But at this point, we're now going to apply, or I'm going to attach the lever arm. Do this by lining it up like so with the along the length of that long stick there. And we're going to do the same process of wrapping the rubber band around the lever arm and the frame. It can be a bit tricky because it's at an angle, but just try and I'm sure you'll get it. Okay. So now that that's done, we have the basic catapult mechanism built. Now we have to attach the bucket, which is going to hold our projectile. We have a bit of glue here. Easiest way to attach the glue in the kit is to peel one side, stick it to the catapult, and then peel the other side. If you don't do it this way, you'll get the glue all over yourself, like a big mess. So once you've done that, you can now attach your bucket, which is in this case our bottle cap. I want to push down. The glue won't stick if you don't push hard enough, so apply some pressure there to make sure the cap stays on. Now you now have a basic catapult as described in the kit. So we're gonna now make our projectile. I didn't show this on camera, but the way I made it is just by folding that aluminum foil up into a ball as tight as I could. So we're gonna test the basic model of the catapult here. As you can see, it works just fine. It launches just as you'd expect. But now let's talk about talk about the interesting part of this project, which is about the scientific process. The interesting thing is that we don't necessarily have a best catapult. There is no one best way to build it. So it's our job to find a more optimal way of doing it. So we do that by experimenting, maybe finding a different lever arm or a different rubber band. We can really change what we do to the catapult and then see how it affects it. And by doing this, we can improve it and make it a better product. So I'm going to do this a few times. First, I try launching it like normal. So this is, again, the same catapult. Launched pretty well. So let's try changing it. Here, what I do is I'm going to change it so that the fulcrum, which is where the lever attaches to the frame, is really close to the rubber band. I wasn't on camera for this, but I pushed the, I'll show it here. I pinched the catapult all the way up to this rubber band like so. And so while I'm doing that now, and now let's try firing it again and see how that changed it. As you can see, I think it did better. It did better when I fired it that way. So we're going to try it again, but this time let's try changing another thing. Let's make it really close to the end. And as you can see, this completely failed. right? So now we learned something in this process. We learned that the closer it is to the rubber band, the better it shoots. This is an important example of the scientific process. So now failure is perfectly fine normally in the scientific process. We just rebuild our catapult. As you can see, I'm attaching the bucket again. And we have a new catapult and we're ready to experiment some more. So now I was thinking, what if a smaller projectile would do better? So here I am ripping the aluminum foil to make a smaller projectile and see how that performs. So this is now a half of a sheet of aluminum foil, which it could be anything you have around your house. You could use, again, Fruit Loops or, whatever you want. You feel free to talk about how your choice of projectile functioned. But here I am folding it up, and we're going to try shooting it and see how it does. Okay, so there you can see that I now changed it so that we learned that the best way to operate it was having the catapult really close to the rubber band, having that really close together. And so now that with these two changes, we can see that it did really well, right? So we found something. We found that having a frame that's really close to that rubber band and having a smaller projectile performed the best out of all of our changes. So now let's try changing it again. So for this time, I'm going to change it so that it's a quarter of a piece of aluminum foil. So I'm going to rip it again, and we're going to see how that performs. So now I have a quarter of a sheet of aluminum foil. We're going to fold it up again and see how it does. So let's launch it and we'll see that let's see. And you can see that it didn't quite go as far as the half a sheet. So we know now that there's an optimal size, somewhere between half a sheet and a full sheet probably is the best size for our projectile. Probably closer to half a sheet. So let's try doing something else now. So far I've only used aluminum foil, but maybe there's a better projectile. Maybe I didn't find it, but maybe you would. So one of the things I tried though was paper. So let's try using some paper. This is a quarter of a sheet of paper. I'm going to try folding it up and seeing how it performs. So now that we have it all folded up, we're going to put it into the catapult, launch it, and see if it's better than the aluminum foil. Maybe it's worse. Maybe it does exactly the same. So there you can see it's all folded up, and let's try launching it. And you can see it didn't do very well. So we learned something that it seems like right now it seems that aluminum foil makes a better projectile than the paper does. We'll try it again because that's how we do it. We try to repeat it so that we know that it's not a fluke, not a random chance. And yeah, it really does not perform very well. So this time I was trying something different again. Maybe instead of folding the paper, maybe crushing it into a ball would be better. So we're going to try that this time. And the real important part of this is to to experiment, to try to figure out using your process, using your knowledge of how it's going to react. And like we learned something that now this ball form was a little bit worse than the folded, in my opinion. I mean, we didn't take exact measurements, which is something we could have done. But in the anecdotally, I think that the folded paper was better than the ball, which was worse than the aluminum foil. So I think that's the video I had to share. If there's any questions, anything we'd like to talk about and like me to talk further on, then please put it in the chat. Let me know.
Not seeing any questions right now. I think you did such a great job of explaining it. I know you had mentioned the other day of possibly trying some experiments with a longer lever arm, like 2 popsicles.
Yeah, that's one of the things you could do. You could make a longer lever arm. Try different rubber bands, maybe. Different projectile. Maybe a bottle cap isn't a good bucket. There's really a lot of things you could do to make it a better catapult. So really experiment with it. Feel free to change it. It's your catapult, so do whatever you'd like with it.
Okay, well, thank you very much for taking some time out this afternoon to share some tips and tricks with us. And I think we've got about 10 minutes until our next presenter is up. She'll be sharing with how to do some basic electronics work. And so with those 10 minutes, let's go ahead. I think we'll jump back to some of the Make-a-thon videos, share a few of those with you. So here we had one of the videos. This was for the snack dispenser. I thought it was really cool. Not only did they share how it works, but they also were able to kind of share some of the data. So they're showing you the ultrasonic sensor, kind of its signal bouncing back and forth and showing how far away you were. And that's how their StudyTron was determining whether or not you were sitting at your desk. And then they were also measuring time. And if you saw in the background, when they showed you kind of the inside of the Study Buddy, you could see how they were using the servo motor to shift. Once again, we're using these great craft sticks to shift the position of that and enable it to dispense the candy. And then those same types of sticks, I think, were used to make this fan here. Let's see if we can find the video for that.
Coffee out 1 degree a second. So 72.
And the whole idea behind these series of challenges is they were intended to be hands-free. So they were supposed to use the sensors to really activate that motion. You can see in this case, they were using a temperature sensor. So in order to show us the demonstration, they had gotten out the hairdryer to heat up that temperature sensor and then activate that fan. You saw the fan continue to run until the temperature dropped. And then you saw then it stopped spinning. And this particular one, I believe, was awarded one of the most aesthetically pleasing. We were really impressed on how they not only created the fan with the items that were in their kit, but then found some household items such as Legos to really dress it up and kind of take it up a notch. And so, as I said, we'll be starting the next session at 1:30. My automated slides don't seem to be advancing at the moment. So rather than show you this morning, schedule some more. If Michelle is there, perhaps she can chat with us for a minute or two while we're waiting for the start of the session.
So I am here, Jan. How's your day going?
My day is going well. You want to go ahead and turn your camera on?
I do. I will do that. There we go. All right. So in another minute, we're going to try to do a demonstration of paper circuits. So everybody should stick around for that. I guess about 30 seconds, I'll start talking about that. It should be pretty fun. I did try it out a couple of times, and people are kind of able to do it, I think, from the video. So I think we're going to be able to do it successfully. And if not, of course, we can always rewatch the video if we get behind, or if we don't know what's something that's happening, we can always rewatch the video. And I think it'll be good. I'm excited.
And so, as Michelle is saying, certainly we will, in a week or so, have the entire lineup available on the CLC Engineering YouTube channel. But also for those of you that are watching via the Watch Live button, you can back up and go forward to look at today's events while that is posted today. And so certainly, after Michelle's session is done, if you want to go back and go, okay, let's go back to wherever we need to. I do think a lot of folks are joining us via the Watch Live versus the Zoom webinar. So if you're in the Zoom webinar, definitely post your questions. It'll be to the advantage of those folks who aren't able to ask. When you're watching live, that is kind of the one downside, is you can't be posting the questions. But I guess we are at 1:30, so if you want to jump in and share your presentation with us, that would be great.
Terrific. Thank you, Jan. Thank you very much. All right, welcome everyone to CLC. I know you're not at CLC. I'm also not at CLC. I'm at my kitchen table, or you're probably at your homes as well. But I'd like you to know that CLC welcomes you. So today what we're going to look at, if you have your kits that were sent to you, you might want to go and grab those. And also we're going to need some scissors. So if you can go find some scissors, that would be good. I'm going to start by introducing myself. My name is Michelle Leonard. I'm an electrical engineer. I'm a professor of engineering at College of Lake County. I'm new to paper circuits. Paper circuits are kind of a new thing in the last few years that they've really kind of taken off. But I think they're really exciting, and there's a lot of opportunity for really kind of creative use of circuitry and just kind of like fun projects. And so I think it's worth it to kind of figure out what we're doing in case we ever want to, you know, make a project. Also, an advantage with paper circuits is they tend to be very, very inexpensive. And especially the more creative you are, you know, kind of the less you need to rely on the electronics and the more you can kind of, you know, it doesn't cost a lot. I'd like to start. I have a short YouTube video to show you about a really, really impressive paper circuit project that I found on the internet. And I'd like to watch that first so we have some idea what I'm talking about. Let me go ahead and set that up for you. All right, let me just pause it for a second. So let me just point out what's happening here. So this is extremely similar to the project we're going to try to do today. Of course, the project we're going to do is going to be a lot simpler. But you can see like in the middle of every dandelion on the painting is a sensor, this little round dark sensor. And there's also a chip. And how this circuit is working is very similar to our circuit where we're going to have LEDs. These are light emitting diodes. They're going to light up. But this painting is interactive in that you blow on the sensor. It's really just a microphone. These are very inexpensive. They're probably about 60 cents. If you blow on the microphone, that's input into the microcontroller, the chip. And on the chip is a program, and the program is controlling the LEDs, turning them on and off. So if someone blows in the microphone, then there's a program that runs an interrupt service routine that says somebody blew into the microphone. That means I would like all of the lights to come on and make it look like the dandelion is blowing away. When you write code on a chip like that, on a microprocessor, it's called embedded programming. And right now it's one of the hottest jobs out there. It's something you should consider looking into if you're interested in this type of thing, because there's a huge amount of jobs available, and it's a really growing field. But anyway, microphone, blow on the microphone. There's a program running on the microcontroller, which turns the LEDs on and off. The rest of this is just wiring, power, and wiring to the LEDs. But I think it's really a fantastic project. Let's just watch a little bit of end of this video. Alrighty, so I think that was wonderful. I'm always excited when people can take a little bit of technology and do something really creative with it. I'm hoping that my little presentation today inspires you to do something. Obviously, that's a very hard project that probably took them hundreds of hours to put together. We don't have that kind of time. We're just going to do one simple little thing. But in future, if you're interested in it, that's the kind of thing you could do as a project on your own. You could think of something creative to do, and then use some kind of circuit to, make it happen. So first thing we have to talk about before we build our circuit is this idea of what is a circuit. And when we have a circuit, we usually have a power source. Here I have a 3-volt battery, just like you have in your kits, a 3-volt battery. And I have 2 LEDs, light emitting diodes, and we're going to connect the 3-volt battery to the top and the bottom of the 2 LEDs. And that's going to make them light up because we'll have current that'll flow through them, and that'll make them light up. A couple of things so this is the circuit. It's a little less complicated than the painting, but the ideas are exactly the same as in the painting. So we are going to need to make sure that when we build our paper circuit, that we make a complete path for current. If there's an opening anywhere, the current won't flow. It's called an open circuit. And if the current doesn't flow, then nothing's going to happen. And so we have to be very careful when we do our circuit that we're making good connections between all the parts and between the battery and the other parts. If we do, we should end up with a pretty nice project. Now, here on this diagram that I'm showing you, this is a website called Falstad Circuits, F-A-L-S-T-A-D circuits, and it's a Java applet circuit simulator. It's just a website that you can go to and you can simulate circuits on. So if you ever are interested in doing something like that, you can go to this website and simulate your circuits. In fact, if you go on and think of other ideas, this would be a good place to try them out to make sure they work electrically so that they're making sense. I'm going to show you an example of another circuit, and it is here. So in this first circuit, I have the 2 LEDs connected directly to the battery on both sides. That's called being in parallel. They're in parallel because there are 2 paths for current. You can see the dashed lines running through. That's the current flowing through the circuit. We could additionally build the circuit where we put the 2 LEDs in parallel. And in parallel, it means that there's only one path for current, where the current is going to start in the battery, go through the first LED, then through the second LED, and then back to the battery. Again, we need to make a circuit to come back to the battery. You'll notice this second circuit here on the right, the lights are not turning on. And the lights are not turning on because we don't have enough voltage dropping across those two LEDs. Over here on the left, each LED is getting the full 3 volts from the battery. Here on the right, that voltage is being split in half, and so we're only dropping 1.5 volts across each battery. Now, the question becomes, how much voltage do we need to drop across an LED to get it to turn on? And the answer is it depends. It depends on what color the LED is. That's kind of surprising. Based on the color of your LED, you might have anywhere, in this case from red of 1.8 volts up to blue and white, which is a little over 3 volts. That's surprising because you would think, you know, these are really the same device, but with just different colors on them, different colored LEDs. But really how LEDs work is that the light produced in the semiconductor is the color of the LED. So in order to produce blue light, we need more energy than it takes to produce red light. In fact, blue LEDs were not invented until the 1990s, many decades after the other colored LEDs. We had red and we had green. And blue LEDs were not invented until in the 90s. And in fact, the inventors of the blue LEDs won the Nobel Prize for inventing blue LEDs. There's a really good article, if you're interested in following up on this, at Popular Science, which came out at the time of the award, which answers why would a blue LED be worth a Nobel Prize? It's actually quite a lot of physics went into the idea of blue LEDs. And the invention of blue LEDs allowed us to have all kinds of things that we didn't used to be able to have, like LED screens. When we only had the 2 colors, red and green, we couldn't make all the colors of the rainbow. And so we couldn't make a screen out of LEDs. We needed the blue to combine with the green and the red to make all possible colors. And so it was really a huge engineering feat and very exciting. But you can read this article at Popular Science on your own when you have time. What I'd like to do now is show you what we're going to be doing. Let me get the video going. My email. Okay, so here we go. So here's what the final project is going to look like. We have 2 LEDs that light up and make the card a lot of fun. Hopefully we will have this by the end of the project. So we're going to start with our supplies that we need. If you're like me, as soon as you got your bag, you dumped it all out. It's all over the place now. If you could take a minute and gather up one of the cards. If you haven't cut these out yet, we can just cut it out roughly and clean it up later. A 3-volt battery. 2 LEDs, the color is your choice. You have several choices. Go ahead and pick whatever. I picked the white ones just because I liked the white ones. And we're going to need some of this copper tape. So again, scissors to cut out the paper, and also we can use the scissors to cut the copper tape. All right, so first let's look at these LEDs. So LEDs have to go in the circuit a specific way. If they're upside down, they won't work because they only allow current to flow in one direction. And the way we're going to want to put it in our circuit is we're going to want to have the slightly longer lead towards the top of the picture and the shorter lead towards the bottom of the picture. So we're going to poke these LEDs right through the paper. My advice is to try to poke the top lead through, concentrate on the top lead. The bottom lead will just follow. Let's try that and see how that works. So again, I want the top lead pointing up. I'm going to try to push this through the paper, not into my finger, hopefully. There we go. Pushed it right through. Now if I turn this over, you can see that I have the 2 leads sticking out in the back. One is slightly longer. I'm going to push that up to the top of the page, towards the top of the Baby Yoda's head, and I'm going to put the bottom lead down. So this is the long lead, short lead. Okay, that's important for the circuit to work later on. Okay, I'm going to do the same thing with the other LED. Let's turn the picture back over. Let me straighten this out a little bit. I kind of flattened that out a little bit. I'm going to try to push this LED through the eye. There, oops, I did bend it. That happens sometimes. I just am straightening it out. I'm going to try to push it through again. Let's see. There we go. Okay. I'm going to turn it over, and again, we're going to have pull the long lead to the top of the picture and the short lead to the bottom of the picture. So now I have 2 LEDs stuck through my paper, long leads, short leads on the bottom. I'm going to turn this over, and this is what it's going to end up looking like. Straighten that out a little bit. Alrighty, so now let's get to taping. So copper tape has a backing on it, paper backing. I'm just going to cut a piece off about 2.5 inches long, about this long. And I'm going to peel off the paper on the back. It's kind of far away from me here. There we go. Okay. It's very thin. So be aware when you peel it off that you don't let it curl up because it's very thin. It'll try to curl up. See, like that. All right, so I'm going to take this piece of copper tape and I'm going to put it underneath these positive leads. And I'm going to have extra tape sticking out here on the left. Okay, so that's where the battery is going to go, so we need a little more length to our tape. So again, about 2.5 inches should do it. We need to go under the 2 leads. We're going to do the same thing on the bottom, get the same size tape, peel it, and we're going to put it under those 2 short leads of those 2 LEDs. Okay. All right. If your nail doesn't get under it, you can scrape it a little bit to get the tape off of the paper. Okay. So same thing over here. I'm going to put a piece of tape under the 2 LEDs. Now they're not attached, so now I'm going to take a piece and put it over to make the final attachment. Okay, so this should hold them down nicely. Okay, so we have 1 piece of copper tape under the 2 LEDs, and we have 1 piece of copper tape over, holding it down and making a good electrical connection. I'm squeezing it a little bit to make sure that it's touching it all over. And the same thing on the bottom, a 2nd piece of tape. Okay, 2nd piece of tape on the bottom here. I kind of curled that up. You know, I'm actually just going to cut this little part I curled up right off, and then we don't have to deal with it. All right, so now we have the 2 LEDs secured and electrically connected, hopefully, to this paper. What's left is the battery. Let's open the battery. You might need to use your scissors. I just had to use my scissors to get the battery out. Okay, so the battery has 2 sides, the positive side and the negative side. We're going to want the positive side to be connected to the long lead side of our circuit and the negative side to the short lead side. So how do we do that on a flat piece of paper? We're going to take the positive side of the battery, which if you can read it here, if I put it under the light,
is the one with the words on it. So it says lithium battery, CR 2032, 3 volts, and there's a little plus sign. That's the positive side of the battery. The negative side of the battery looks like cross hatching, and there's no words. It just looks like a pattern, a pattern. So what we're going to do is we're going to take the positive side of the battery, the side with the plus sign, and we're going to put it here, touching the top piece of tape, which is the tape connected to the long leads. I'm going to use some copper tape to connect the bottom, the negative terminal of the battery, to the other side of the circuit. Remember, in a circuit, we need to have a complete path for current. Right now, we don't have a complete path for current, but we will have one once we connect this battery on both sides. So let's do that. So I'm just going to take a short, maybe an inch, maybe a little bit longer, and I'm going to put the tape on the battery, and I'm going to hold the battery on the top copper tape, and I'm going to put that tape down like that. Now, sometimes the battery's a little heavy, so I'm going to add actually a second little piece of copper tape to try to just for support, so hold it on. Electrically, it should be okay with just one piece of tape. And I'm just going to add one more piece of tape. Okay. Apparently that's the hardest one. There we go, to peel the paper off of. Okay. All right. So again, just to make it a little thicker, hold it on mechanically. All righty, so let's cross our fingers. Wish me luck. Let's turn this around.
All right, so those were the instructions. I realize that might have been too fast to keep up with, but again, you can rewatch it if you got behind. I do have a final little video about troubleshooting.
All right, it's time for the big reveal. Here it is. The good thing about this circuit is it's very straightforward, but even so, it's very likely that the first time we do this, it might not work. So we're going to spend a few minutes talking about troubleshooting and getting this circuit to work. I'm going to try to think of things that we might be doing that we can test and try to solve the problem. If you get no light at all anywhere, you don't see any light at all, one thing you could do is you could test your battery and make sure that it's working. So you can do that by taking your battery, and just taking an LED that you have left, in your kit, an extra LED, and we're going to want to put the long lead on the positive side of the battery and the short lead on the negative side of the battery. Now, this is an LED, there we go. So this battery's working very good. If your battery's working, that's excellent. We know that we're getting power to our circuit. So let's try something else. Okay, so we've tested our battery and our circuit still doesn't work. If neither light comes on, it's possible that you did put them on upside down. Remember that the long lead has to be on the top and the short lead has to be on the bottom. If one LED comes on and the other one doesn't, it's possible that you reverse one of those LEDs. It's also possible that there's not a good electrical connection on that one LED. Obviously, the circuit's working if one of the LEDs is lighting up. So it's possible that we could maybe put a little bit more wire, a little bit more copper tape, and connect that LED to the circuit a little better, or squeeze the tape so that it's touching really well. So again, things to check. If it's not working, check the battery. You can do that separately by just putting an LED, like I showed you, a positive side of the LED to the positive terminal of the battery, negative side to the negative terminal. If it lights up, then the battery's working. And once we put it back in the circuit, if only one eyeball lights up, that means the circuit is working, that we have current flowing in the circuit, but it's possible that one of the LEDs is backwards, upside down, or not a good electrical connection. So those are some things you can work on. This project can be expanded. There's enough materials in your kit that you could do a couple more. But in addition, you could use your creativity and come up with something pretty impressive. Good luck with that. Right.
Okay, so we have a question. Where did the question go? The question was about, the question was about the battery. The battery should be facing down. The plus side of the battery should be facing down on that top piece of copper tape. The negative side of the battery should be facing up, and then we're gonna tape it to the bottom half of the circuit. So the plus side of the battery should be touching the paper, touching the copper tape on top, and then we add a little connection of copper tape to the bottom row. Other questions so far? Other questions or comments?
So Michelle, I'm not seeing any other questions right now, but I'm sure anybody who has the kit probably has, 7 or 8 LEDs in there. How many LEDs at one time can you light up with that small 3-volt battery?
So you can probably only light 2 up in parallel with the single 3-volt battery. What you could do is you could get a battery from around your house, like a 9-volt battery, and then you could light up a lot of LEDs. I think that it also, like I said, it also depends on the color of LED, how much voltage you're going to need for each one. So if you had, for example, red LEDs, you could get a few more in a circuit. They don't take as much voltage than say blue, which would take up the whole 3 volts. Basically, blue takes up all 3 volts. But yeah, so additional batteries or a larger battery would be fine if you're doing projects. You could just connect either the copper tape, or if you have a wire around your house, you could wrap the wire around the 2 terminals of the 9-volt battery, and then connect that to the paper circuit with some copper tape. It wouldn't be as mobile as with the CRV battery, but still, you could do some impressive things with a paper circuit. Other questions so far? I do have one little short video to look at, if you've got a second left for me. Here's another project. We couldn't really do this one. It was too long to do today, but I recommend you look this up on the internet. This is Make Zine. This is an origami jumping frog, and it's a very, very similar circuit. But you would first build this origami frog, and then we put the very similar circuit to light up the LED eyes. This is a real fun one. It helps if you have a thick paper, like a cardstock paper. But it's a very fun project. I'm going to just speed this up a little bit. So this was a lot of fun. I hope you guys had a good time. Again, review the video if you're having a little bit of trouble getting the circuit to work, but I'm sure you'll figure it out. And again, creativity is the point. Think of something interesting, and we'll be able to add some LEDs to it and make it fun. Back to you, Jan.
So thank you, Michelle, very much for sharing that with us. And once again, for those of you that picked up the kits, I think there was a combination of regular paper and some cardstock in there. So as she said, I think that was Make a Zine, or just look up, origami LED frog. I'm sure there's a few of them out there. I think that'd be a really cool project to make. Or as she said as well, you know, you've got those LEDs. You've got, I think, some cardboard in the kit or other things. You know, you could make up a house and have the windows light up, or various other creative options. So thank you, Michelle. And I think we're going to move on next to Philip, who's going to share with us how to make a gravity roller.
Right, hello. So welcome to the Lake County Maker Faire. If you haven't seen me before, my name is Philip Sandermone. I am one of the Baxter Lab Innovation as interns, and I'm also a second-year student here at College Lake County. So for today, for this portion of the Maker Faire, we will be building the gravity racer. Now, for this presentation, I will be showing a pre-made video. It's just to help show you how I did it, as well as to be able so I can narrate over it. So if there's any questions, I can just pause the video, and I can make sure that everyone is caught up to speed. All right, so now before we begin, let's make sure that we have everything. So inside of each of the bags that you should have received, they're like this. One of the kits you should have is called the gravity racer. This is what it looks like. And so inside of it is basically everything that you need. Inside we have the instructions kit. And of course, if you look inside, there's just additional instructions if you do need it, and they're also in Spanish. You'll also receive these paper straws. So there's a bunch of these paper straws. This is more if you did mess up. You don't have to worry. There's a bunch of other retries you can do. So yeah, inside you'll also receive 2 wooden sticks. They look like these. Now with these, I would be a bit more careful because you do only get like 2 of these. So if you are going to cut them, just make sure that you know how much you want to cut off. All right, and then 2 other things, you should receive 2 big wheels. These are going to be used for the back. And then 2 small wheels. These are going to be used for the front, as well as a bunch of rubber bands. Now, these are going to be used for make sure that we can actually connect everything together and make sure that nothing falls apart. Now, to be able to use it, there's another tool in your bag, scissors. I think you should have all received these. These are going to be used for cutting the paper bag and the paper straw, my bad, and the wooden sticks. So if you don't have a pair of scissors, I'm pretty sure you can find them around the house. But other than that, let's begin. All right, let me share my screen real quick. All right, so here I do have the video. Again, this is just to start off. This is just the supplies you would need. Generally, you would only need 4, but if you do need more, there's plenty of more. The 4 wheels, the rubber bands, the 2 sticks, and the scissors. So I'm gonna start off this video. So what I'm doing here basically is just starting off by cutting off the back end axle of the wooden stick. So I'm just gonna pause it here real quick. So again, it should look like this. You want to cut it to length, just so that it's a bit more even for your race car. And so we continue with this video. It will be a bit hard with scissors, just so you know, but it should be working just fine. And so with that, I'll be taking another paper straw and I'll line it up together. So it looks like this. And so when you are cutting it, you do want to cut it a little bit shorter. So what I usually do, you can aim for 1/2 inch to a full inch. Though what I usually do, I just do the thumb roll where I put it up and I can see if that's how much I want to cut. And so when I do that, it should look like something like this, where the wooden stick is still taller, but the paper straw is a bit cut. And if we continue with this video, you're going to see me do that. Though it is a bit easier since I have done it a bit more. There we go. I just want to cut it just to length like that. Snip, snip, snip. There we go. And so once I have that done, I'm going to be creating this first wheel or pair of wheels. So I'm going to attach the wooden stick together and paper straw, and then followed by the wheel. So this is mainly just to make sure that everything works. Though once you do put this together, you want to make sure it works just like this. And if it does spin, then you know what you're doing correctly. So other than that, for right now, we are going to take this apart, but for right now, just put it to the side. And we're going to do the exact same thing with the front wheel. So I'm going to continue playing with this video. So you put it together, and for right now, I'm going to put it to the side. And so for the second one, I did have it pre-cut in this video, but essentially it should be smaller than the back end and exactly doing the exact same thing, lining it up together, just like that. And make sure it is cut a little bit more smaller than that. Again, you can do the 1/2 inch to 1 inch, or you can use the thumbnail. And in the end, it should look, I'm gonna keep the video playing, something like this. And then you're gonna do the exact same thing where you put it together with the front 2 wheels. Ta-da, like that. And it should do the same thing where it can be able to spin. That's just to make sure it works. So now that we have both of our 2 wheels ready, we're going to take it apart again. And this is going to be the more difficult part of this build, but it's just a little bit tricky. But other than that, we should be ready to go. And so now we're going to be focused on building the actual body of this race car. And so for this, I would recommend starting with the back end, or the first part that you cut. And so with that back end, you're going to take it and you're going to take one of the regular long strips. So this is the back end and this is the long strip. And you're going to put it together just like this. And so you'll see in the video, once I attach it just like that, I'm going to put a rubber band over it, just like that. And so it should look something like this. And what you're going to be doing, you're going to be tying it around just like that. And so it may be a bit more difficult, but it should be able to work out just fine in the end. And for this, I would recommend doing it around 2 to 3 times, or actually 3 to 4 times, just so that it's tight enough, but not too tight. All right, you just see me doing it right here. All right, that should be the last one. And so once you do have it like that, you know that you're on to ready for the next step. And so once you do have it something similar to this, what you're going to do is that you're going to take it and then flip it, keeping it like this, where it's again the long stick, the short stick, and then the part here. And so we're going to flip it. I'm going to do the exact same thing where we take our rubber band and our pieces together and just tie together like a hair knot. And again, when you are doing this, you want to make sure that you're doing it the same amount of times you did do it on the first set, so that when you do it, it should look something like this. Or you'll see in the video very soon, just like that. Now we're going to be doing the other side, just like we're going to copy it how we did it on the side we just did. Though just to be sure, when you are doing this, make sure that you are doing it on the same level. So if you see this one here, it is on the top side of the straw. You want to do the exact same thing with this one on the same side. All right, and continue with the video. All right, and again, it will be a bit more tricky, but through sheer perseverance, you should be able to do it just fine. Again, tie it anywhere from 3 to 4 times just to make sure it's tight enough, but not too tight. There we go. Once you have it like that, we're gonna twist it a bit just to the other side, just so we can like get that extra tension in the opposite direction. And again, this is more of the difficult part, so take your time with it. All right, in the end, it should look something like this, where you have both of them being able to go straight, or at least leaning toward the center a bit. There we go, just like that. Now we're going to be focusing on more of the middle part. This is going to be focusing on the shorter part that you did cut. So what I would do instead first to prep it is to be able to put these two together. You'll see right here what I'm doing. And so that's what it looks like when it's done. But first I'm going to make sure that these two are together. So this is a bit more slippy, but essentially you're going to do the exact same thing just to tie it down though. And so for this front part, you will need 3 rubber bands, at least the way I did it. And so once you have it together like this, and don't worry if it does bend, that just means it is a little bit too tight. So you can just remove the band one time. But there we go. Here's the other part. And so what I'm going to be doing, the exact same thing that we did with the other side. I'm just setting it up first this way. So here's my one rubber band first. I'm going to tie it around 3 or 4 times. There we go. And I'm going to twist it the other way. Once we're done with that, I'm going to tie it the other way, just like normal. And so what you should have in the end, if it does straighten out, or when it does straighten out, it is a bit too tight, so I'm going to have to retie it real quick. And just like that, it should straighten out like that. Pull it out real quick just to make sure it works. Looks straight. There we go. And so I'm just pause it right there. So in the end, right now, what you should have, or what you should be left with, is something like this. So for right now, I have a triangle shape, and this is what I did in my video. And essentially, once you do have this, all you really have to do is do the final step of attaching the wheels. So again, with the axle and the big wheel in the back, and the small wheel in the front, as you'll see in the video. There we go. And then from there, you should have your very own gravity car or gravity race car. And so again, just to make sure it works, you can spin the wheels, both sides. And I'll show an example of me doing this real quick. Here we go. And so right here, I just have it on a level or like a ramp slope type of thing. So when I do drop it, it should just race it right across. I'll play the video. And there it goes. All right. And so for right now, what you should have or left with is this. This is your very own gravity racer kit. So for right now, while people are still finishing up, think of ideas that you can be able to spice it up a bit. If you have a little bit more extra straws, maybe you want to do it with a different design, maybe a square, or maybe something else, add some flair to it. But in the end, if you do want to be able to try this out yourself, you can do it on your kitchen floor or pretty much any smooth surface. Just make sure that all the wheels are able to move slowly like this, and then you're set. But other than that, I'm pretty sure that's it for my presentation. Ms. Edwards?
So we have a question from the audience. Why is it called a gravity race car?
Oh, okay. So technically, how I would describe it as like more of a frictionless type of race car, just because of how when you do have that straw and you have that stick inside of it, when it does spin, there's not as much friction to it. And so while it's called a gravity race car, I would call it more of a frictionless type of race car. But yeah, I think that's pretty much how it works. It works for both the front and back. And so since the axles or the wooden sticks are smaller than the paper straws, it should be able to allow it to spin more freely.
Okay. And certainly you placed it on the ramp, so we were taking advantage of gravity. We don't have a motor of any kind.
True, very true.
Do you have any other designs around that you could show?
Sadly, this is the only one I have right now. Though I have seen some designs where they just use the paper straws for like I don't know how to. They made it look like an actual race car, which is really cool. And so if you do want to be able to add stickers to it or color the paper straws in any way, that'd be pretty nice as well.
Okay, so we could like build upwards with the straws and make kind of like a dune buggy or something. Cool.
Yeah, definitely.
Okay. And then certainly I'm sure if folks around their house have like Connects or maybe Legos, they could probably grab some wheels from those and come up with some different designs with those as well.
That would be very awesome. Very cool.
Any other questions from our audience? Anybody having problems with the rubber bands or anything else they need repeated? Okay, well, Philip, you did a great job. Everybody seems to be pretty clear, and we got a nice thank you from the audience. So
thank you very much.
I'm glad to hear some people are out there building these cars.
Oh,
and certainly, you know, we don't really have it posted anywhere, but we've been doing things on the CLC Engineering Facebook page for the last month. If any of you, create something and you want to go ahead and post things up on our page. We'd more than welcome some submissions. Okay, so Philip, thank you for your time. I think as you mentioned as well, you're one of our CLC engineering interns working at the Baxter Innovation Lab on campus.
I am.
During a typical year, which is have 10 to 12 interns who really keep the place running for us. They keep the equipment going. They do demonstrations on the equipment. They teach other people how to use it so that our other students can get those opportunities as well. And many of you, like Philip, will be graduating this year, so we congratulate you on that and wish you well.
Thank you very much.
And I see we currently have Joe here from Cook Memorial Library joining us next. So Joe, if you want to go ahead and get yourself set up, we're eager to hear your presentation.
Sounds good. Hi, everyone. How's it going? Like Jan said, I'm Joe. I work at the Cook Memorial Public Library in Libertyville. I'm a reference librarian by day and a makerspace guru by night. So I prepared a short presentation to give you a brief rundown of our history. I'll be giving you the 10-cent tour, and then I'll cover a bit more about what we do here, and then open up to questions. So without further ado, let me share. And here we go. So, the making of a makerspace. We started out putting together the beginning plans for a makerspace back in 2015 when the Board of Trustees put forward the strategic plan for 2016 to 18. They called for the creation of an area in the library where patrons would be able to discover technologies that enhance and create enhancements for creativity, and provided the opportunity to discover various kinds of tools, gadgets, and what have you that would enrich their lives. Working group was formed to that goal in mind, and afterwards, I came on board. Myself and my coworkers visited a number of local libraries to get some ideas in terms of what had been done already. We had a ton of different meetings and a lot of learning, but in late 2017, we began moving the equipment that had been in what is now the workshop, our name for our makerspace, which had been the digital studio, and we prepped it. Materials and equipment began coming in April 2018, and we held our grand opening January 12th, 2019. As you can imagine, it's been a relatively short run given the pandemic happened about a year later. But in that time, we've been able to have over 524 patrons come in, either attending various programs or making use of our open lab hours. Speaking of which, let me start video. And let me verse. Here we go. So here is a bird's eye view of, I don't know, why am I not? There we go. Our makerspace. So if you were to come in on a normal day, you'd see first a sign-up sheet for liability waiver. It's more just to cover ourselves and also to have an idea of who's come in, keep a record of that. The workshop has 5 rubber sewing machines. It has over 100 different decorative stitches, along with a number of other things you can do with it. Hold on. Here. Sorry. We also have pretty much all the tools you can need to go along with it. Multiple soap, multiple scissors, cutting mat, book with some really great materials on basic sewing, different patterns. We also have a couple of different button makers. You can either do 2.25 inch or 1 inch, and they've been very popular. As you can see over here, this is kind of our tour of what we've done over the past year or so. One of the more popular things we've done is the pour painting, which has been just extremely popular. We've also been doing some paper quilling, which actually came out really well. I was really impressed with what our patrons were able to do with that. Beyond that, on the more high-tech end, we have 2 Oculus Quest VR headsets, along with 2 Oculus Go headsets, Google Cardboard, and a PS4 VR headset. We also have Lego robotics kits, which kids have had a blast with, and multiple different sewing accoutrements. Beyond that, we also have a vinyl cutter, which can cut both acrylic and iron-on. You can also use it to do paper, cardboard, and felt. Felt can get a bit messy, but it's gotten some really great results. With that, we use Silhouette software, which is the designing and cutting program that's used along with it. And just recently, we got in probably my favorite toy of all, the Prusa Mini 3D printer. Right now, I'm currently using it to print the parts for a miniature drone, which is actually coming out pretty well. Oh, and speaking of my design cutter, here's probably another one of my favorite programs I've done. Paper cut flowers. This has been extremely popular, and I've done it multiple times for different patrons. Beyond that, we've also done some other sewing programs. We've got a doggy blanket and shoe toy, which were actually donated to a local pet shelter. And let me... There we go. Switching back. Can you see me? Let's see. Okay, excellent. For some reason, I'm not seeing myself. But going back to the presentation, let me present. After the opening of the first workshop, we decided we needed another one. So the Cook Library operates out of 2 different locations. Both our location in Libertyville and in Vernon Hills. So around the same time we were planning the creation of the first workshop, plans were already in place for an expansion over at our Aspen Drive location, which opened November 2019. So we had even less time than the first, but provided us with a lot more space, allowing us to have much larger programs, and also enabling us to reach out to other patrons who might not be able to make it in or who was much more convenient to go to. When the library closed down March this past year, we immediately pivoted at first to virtual programs, in this case blog posts, before we were able to get in place the procedures needed to safely get patrons the kits, which we use to give them the materials for programs. Once we got that down, it was just a matter of putting it all together and setting up a Zoom chat where we could go in. I could go over the instructions with a slideshow a lot like this. And it's been really fun putting them together, honestly. It's good to see the patrons, even if it's not in person, and some of the crafts they put together just blown me away. And so with all of that, going forward, granted, we're not open just yet, but I am looking at the potential, hopefully in the nearer term future, of acquiring a laser cutter. That's my dream piece of equipment to get. And because of, if and when we are able to get it, it would open up a ton of new different kinds of programs I would be able to do. And I am just so looking forward to eventually getting my hands on that. But beyond that, any questions?
So your program is certainly geared.
Hold on, I can't hear you. Why can't I? Oh, sorry, there we go.
Your program is certainly geared towards your patrons. Are more of your programs geared towards younger kids or older adults, or is there a mix of programs?
We tend to split it up. I am in charge of both teen and adult programs, but there's a surprising overlap with them. A number of times I've done programs for teens, and then when the adults see it, they're like, "Can we do that?" So I actually had a faux butterfly display program for teens this past spring, I had a number of patrons asking me, adult patrons asking me if they could do it. So I've already penciled that in for this coming summer.
Okay.
Beyond that, we've also done a number of different sewing programs, everything from gardening gloves to scarves. We had a really popular one where people were doing felt coasters. So these were fairly popular. But it's been nice. Like I said, I'm looking forward to eventually expanding what our options are in terms of equipment. But so far, despite the fact that half our runtime in terms of how long this place has been open has been virtual, I've gotten a great response.
So just to remind me, because I know every library is a slightly different status, are you doing appointments at this time, or you're completely closed until a set date?
Unfortunately, we're completely closed physically, and we don't have a date yet in terms of when we be reopening. But like I said, we've done a number of virtual programs, and I've really tried to, especially with regards to my blog posts, which I called my Workshop at Home series. I tried to expand the kind of things I included. So I included a, hold on, what was it? Like how to make, let me find it here, hold on. An ubi roll, which is something which I never thought I would do, but let me bring up a picture of it. Here we go. So this is a picture of one of the things I provided instructions on how to make, an ubi roll. It's high fat, but delicious. And that's something where we're not really able to do food type programs here, but that was something I'd really been trying to find a way to incorporate into the kinds of programs I've been doing. So that was a unique opportunity.
And then you said your blog is on the website. Does the website for the library also have then like the list of types of equipment? Is that where we'd find out more program information?
Yes, if you go onto the library's website, give me 1 second. And look up services and go from there. I can show you the website itself. So we have a rundown of all the different kinds. So we have basic here. We have what had been our hours of operation, brief explanation of what a makerspace is, along with a place where you can, okay, so despite being closed down, you can still submit 3D print shops. But it lists all the different kinds of equipment we have. It has links to the different software we provide access to, policies and prices, and a waiver you can digitally download and then bring in back when we actually had people coming in. But I have to say, overall, it's not something I trained for. I had a bit of experience from my previous job, and since then I have really grown. I never thought I'd be doing these kind of programs, and I've been really enjoying it.
And I think that's the same story. I know we've got a few more makers who are going to be joining us for this last talk. That the idea of making is you just jump in with both feet, you learn as you go, and the more things you make, the more things you want to learn how to make. It's just one of those things.
Exactly.
So thank you, Joe, very much for that kind of sneak peek into your facility. And like I said, we'll be sharing these videos out for folks to take a look at if they weren't able to join us today. And it looks like next we've got Dane and Tina and John all here to talk to us a little bit more about the createry and some other making that's happening in the Midwest.
Sounds good.
So, Joe, thank you for your time.
Sure thing. Bye.
Thank you, Jan. Hi, everybody. My name is Tina Baldwin, and by day I'm a K-8 art educator, and during healthy times I have the pleasure of teaching maker camps in the amazing Baxter Innovation Lab as part of CLC's Explore program. But I'm I'm very happy to be here today as co-founder of The Creatory. The Creatory is a 501c nonprofit that is working to become a maker space. If you didn't get a chance to see MHub's tour or MXD's tour, I know I was very inspired by those presentations today, and they are great examples of what we could shoot the moon to be in terms of a space. We would like to provide that opportunity closer to home in Lake County for all of our Lake County residents of all ages. Today, I'm very happy to announce a new initiative I'm going to be calling the Lake County Maker Education Cohort. With the mission of providing maker education opportunities for all of our K-8 students in attending Lake County schools. I have two presenters with me today. I'm very happy to have Dane Ellman and John Riley joining me. For our first presentation, I'm going to turn it over to Dane as STEM coordinator for Gurney 56. He is going to share some of the projects that his students have done as part of their school day. So I'm going to turn it over to Dane. Thank you.
Good afternoon, everyone. So yes, Tina asked me to speak a little bit about maker education in my school district. And I'm more than happy to come here and do that. So I've got a bunch of slides to share. So let me get that up. Okay, so hopefully you're seeing my slides, and like she said, I'm the STEM coordinator in Gurney District 56, and which is includes 4 schools in Gurney and Wadsworth. And first, a brief history of my involvement in Maker Ed. So I was a middle school technology teacher for a number of years, and then my district adopted one-to-one iPads in 2012, and so then I realized that now every teacher was a technology teacher, and I had to figure out how to kind of reinvent myself. And so I started incorporating tools and materials to complement the technology in my class, and that quickly got out of hand as I collected a lot of those tools and materials. And then the superintendent caught on to this growing trend that schools were starting to include spaces where learners have the opportunity to explore their own interest, to tinker, create, invent, and build using the widest variety of tools and materials. And so I was offered a district-wide STEM coordinator position where I was given the task to set up maker spaces in our schools and promote maker and STEM learning. And so fortunately we had the perfect space in our schools to do that. So in the middle school, we had the perfect room to turn into a maker space and to turn into a STEM lab. And then we started inviting students in, and one of the first projects I did was ask students to make this decoration for the wall in the makerspace to make it look more inviting. And we didn't know when we built the makerspaces, if we build it, would the teachers bring their classes in? But they did. So we had enough curious teachers that wanted to see what it was all about and inspire their students to start creating stuff for their classes. So They used 3D pens, and science teachers did a cell project where, traditionally when a whole class does a project, all the students turn in the same thing, something that looks the same, they're coloring a sheet or something. But now when you're doing something in a makerspace, you have all these different materials that students can use. And so everyone can turn in something different and learn how to use different materials and different tools. So students did use 3D pens to make their cell project, but they used a whole variety of things, anything they could find. We had a 3D printer, and so some students were curious about how to do that. And so, while they were, experimenting with materials or experimenting with 3D printing, they still had to think about what they were going to use to represent the different parts of the cell. And so they were still doing that thinking to learn what the content was. Language arts teachers brought students in to make posters for books they were reading. The art teacher, who was more of a traditional art teacher with a painting and drawing and clay, took a chance also and challenged the students to create art with recycled materials. PE teachers brought students in to, found a project online to create climbing holds for the climbing wall. And so he took a chance on that. That involved this fluorist foam and silicone, and they created these climbing holds that they actually ended up putting onto the climbing wall, and so the students actually got to use them. Students started working with tools that they've never worked with before, learned how to cut PVC pipe and drill holes. Here's a fourth grade teacher told me she wanted her students to create Harry Potter wands and asked me to bring in 12-inch dowel rods so the students could decorate them. And I said, okay, I'll bring in the dowel rods, but the students are going to cut them themselves. And she said, no, they're only fourth graders. They can't cut them themselves. And I said, I'll tell you what, I'll bring in the dowel rods. Any student who wants to cut them themselves will be able to do that. Any student who doesn't, I'll cut them for them. So how many students do you think wanted to cut their own? All of them. And they enjoy doing that, and they learn that they are able to create something and use those tools. Students learned how to solder. The band director found a piece of music called Foundry, where it involves the percussionist just hitting some scrap metal. And so the band students went into the makerspace and put together a bunch of scrap metal that they got to play in a concert. I had a science club where we built and launched rockets every year. And I was used to giving everyone the same rocket kit to build and launch. And this, changed my mindset a little bit also, because now I was able to just challenge the students to go and build their own rocket out of whatever they could find, all the scrap pieces there. So they did that. Students got to build balsa wood towers, and they loved doing that. Well, the favorite part, of course, was smashing the towers afterwards. So they got to see how much weight the towers could hold. And after they built them, we asked them to guess how much weight their towers could hold. And of course they said maybe 20 pounds, 25 pounds, and they were astounded that they could hold hundreds of pounds if they engineered them correctly. And let's see, I do have a video, but I might have trouble with sound, but I can still play the video though. And this is the students reacting to it.
Oh my God! 405 pounds! I still think it. Bro. Oh, 405.
So I'd never seen, it's rare to see students that engaged as when they're watching those towers withstand or break under the weight. Students created fraction pizzas in math. This was using a green screen to make a video about fossils, and they put themselves in the area where those fossils could be found. And then I've a pretty good record of a lot of the other projects on my Twitter account, so I'm going to show some of those. So we built balloon-powered cars to help us understand Newton's laws in 5th grade. students hosted their Epic Build Showcase where they demonstrated coding in Scratch, Scratch Junior, Mindstorm. 8th grade students coded the Sphero to trace out their original shape and its reflection in the coordinate plane. So this was just taped out on the carpet, and then they used Spheros for that. 4th graders were amazed at how many blocks their boat could hold without sinking. 5th graders learned how coastal engineers prevent flooding, and then they built a helicopter suspended devices to rescue tsunami victims. 5th graders read a book called Beauty and the Beak, How Science, Technology, and 3D Printed Beak Rescued a Bald Eagle. And then they designed prosthetic limbs for tiny animals, and we printed those out and they attached those. And actually, I was in a virtual 3D printing conference I don't know, within the last year, and I don't know how I found this. It came in my email, and I'm like, oh, this looks interesting. I'll attend this conference. I didn't really know the organization putting it on. And the presenter was going through their slide deck, and this slide appeared in their slide deck. I'm like, oh, that's me. That's my tweet. So it must have been interesting to them too. This was a Spanish class that used 3D pens to decorate 3D printed skulls to celebrate Dia de los Muertos, Day of the Dead. Math and language arts together. This class calculated, measured, and cut the muntins in order to build windows to represent the main characters while reading a book called The View from Saturday. So muntins, I learned, are those decorative slats in windows. This 8th grade class built and tested gumdrops and toothpick bridges in the STEM lab. We had a cardboard challenge for the entire 5th grade where I gave them a ton of cardboard and masking tape and cutting materials, and they just planned and built things all, they spent about a week doing that, and then they toured throughout the school all of the creations that they had built. It was a really fun project. 8th grade art classes lit up their awesome decoupage glass bottles. So this was that same art teacher who came to me and said, do you think we can do this? Do you think we can decorate this, and can we make holes in these bottles? And I said, I'll figure out how to do that. So I researched how to drill holes in glass bottles, and I went and bought the right drill bit for that, and I went up to the art class and I let the students do that and drill the holes themselves, and then they decorated them and lit them up. This group of students built a Lego Mindstorm powered Ferris wheel to symbolize the novel they were reading. This class, well, the way I worded it, as a reward, this class chose to study the chemical properties of combining polyvinyl acetate and sodium tetraborate, or in other words, they got to make slime. This was a math class that measured and weighed out various ingredients to find the perfect pancake recipe. This was another math class, created their own carnival games. This was a social studies class that created Sphero chariots, and then they learned how to code those. And this was a club that I have, it's called Math Shop Club. And we built catapults and trebuchets for Punkin' Chunkin'. And so that's some of the projects that have been done and documented. And after a year of trying to influence this maker mindset in my district, I thought we were ready to take it to the next level. And so I planned to carry out an official maker fair, a school maker fair, which we did, and that was April 11th, 2018. Turned out better than anyone could have imagined. We had, I think, 55 different booths, but it turned out so great, mostly not just because of everything the students were making, but rather because of the larger maker community who were happy to come in and set up booths in order to inspire the students and the families who visited the maker fair. At first, I thought it was going to be mostly booths of students. Actually, the first idea was it was going to be like science fair with a lot of other making stuff, but it turned out that most of the booths were from outside the school. They were community members who came in just to show what they were doing and to inspire the students. So we had one more successful maker fair the following year, and then the third one that was scheduled was for March 18th, 2020, and that was little less than a week after everything shut down, and we had to cancel that one at the last minute. But hoping to keep that going, and that takes me to the end of what I was going to show. So I'm going to send it back to Tina.
Thank you so very much, Dane. Like I said, a great maker education program, very successful. And Dane is thankfully willing to share his success and his knowledge that has gotten them there to also encourage our Lake County maker education cohort to help pass along and encourage this to be happening for all students in Lake County. And so with the formation of this Lake County cohort, we're hoping to bring maker education to those students that might not even have spaces in their school. And to help me explain how that is going to happen, I'm going to invite John Riley of Maker 13 to share his success story with the Maker Mobile.
Sure. Thanks for having us, and thanks for having me. I'll share some slides now if you guys can hear me okay. You might be able to tell we're always on the move, so I'm actually traveling right now across the state. We're located in Indiana, but we travel all around, and that's something really cool with the mobile initiative that we have, is that we can go wherever it's needed most. And so I'll share a few slides of our physical space. And we started with the mobile outreach. We started by connecting entities that exist in the community. So like library makerspace, like the school makerspace, connecting them to the community and the region as a whole. Something a little different, a lot of education background that you guys have here. We try to tie it in a little bit to the manufacturing background. Who are the outlets in our community that will pay you guys a lot of money to be makers for them professionally? We talk about a lot of hobby things and creativity and all that kind of stuff. In my background as an engineer and the manufacturing company I work with, we're always looking to hire makers. And so that's really what started our movement, if you will, in the southern Indiana area. And so from that, we've been able to go to a lot of communities to help them out and to explain how we do it with a mobile outreach and how we connect different entities. So I'll share a few slides here, and we'll kind of bounce through a little bit of our history. So the Maker Mobile that we have, we designed and developed in 2014. It's right near Louisville, Kentucky, is where our headquarters are. And so far, since 2014, how we've gotten out and about, you kind of see some of the numbers there, through some of the visits, the big shows, the big fairs and things like that. We've probably seen over 400,000 people, families, kids, students from schools and all that, racked up about 10,000 plus volunteer hours, and scattered over about 450 events. And I'll kind of show you where some of those were as we go through. But what that did was laid the foundation for our physical space that launched a couple years after the mobile space. So it's a 10,000 square foot workshop, similar to what you may have had a tour of earlier in some of the other panels. But we've helped launch multiple small businesses. We've got about 100 active members now. Even with the closure and shutdown that we had, we were able to keep the small businesses open and working, which was great for the community because a lot of them either didn't have a job anymore or it changed. And so being able to allow that access to makers and to have a community resource like what you're striving for is really important for that. Not just an outlet for education, but an outlet for jobs and small business creation. So this is what the trailer looks like, the equipment on there, and it rotates around depending on where we're going. And so if we're going to a school that has a 3D printer, well, maybe we'll take the CNC router. Or if there's a school that has another piece of equipment, we can swap it in and out and be modular enough that we can kind of fit wherever we travel to, or supplement, an existing program in a school or education entity. Here's some pictures that we had where we were actually in the VEX Robotic World Finals, where we pulled the trailer inside. This is how we met at the Milwaukee Maker Faire. where we were able to go and be inside the Maker Faire. And, there's been panels about making the pneumatic rockets. That's a great intro thing because you could show the creativity with just paper and scissors. And then we take that and elevate it with the lasers, 3D printers, and CNC equipment. And we even had a repair shop for the Vex robotic guys. When they broke their robots in the competitions, they were able to come and fix them there. We also inside, again, at modular, we can move things around, but this is kind of how the inside works. Where again, we open up, we go to where the community is. We open up and really share what is possible. And then we make sure we point them back to the closest place. So if the library is the closest place, go there. If the creator is the closest place, go there. And so it's really important to connect that network to all makers to make sure you're enabling and empowering where people are, where they are demographically, economically, wherever, and get things in their hands. Again, could be as easy as scissors and tape, or here's a laser, come play on that as well. Here's where we're kind of based out of. So we're in Southern Indiana, but the stars of where we have gone. And so, out of those 400 plus visits, the bulk of them there are in our immediate community. We go into the kind of the lower income or rural communities, and then try to draw people back to either our space or one of the regional libraries that we have. But yeah, we took it all the way to the big nationwide New York Maker Faire a couple years back, and it was a lot of fun to do that. Am I still with you here?
No, we can hear you now.
Okay, you can hear me now, but the screen's gone. I think it's going to come back up. But
I can go ahead
With the
and John,
mobile?
I can go ahead and share the presentation from my screen. That's okay. It'll look a little
awesome.
different.
Yeah, no, that's great. We'll pick up from the map, and again, it's really about going to the communities that need it, connecting those entities, and making sure people have access to it. Part of our region, we have a lot of manufacturing in our region. In Wisconsin, Illinois, Tennessee, all those are in the top manufacturing jobs in the country. And so it's important to connect the maker community to the manufacturing community, and kind of make that network. And so that's really what we're excited about coming up and helping you guys. If you need to get more people on board and get more people excited about making, we can, go to them where they are to explain what you're talking about. Because if you're not in the making, it's hard to explain that. But if you can show them, invite them in and let them work with some of the equipment, what you're doing, that's more exciting and more impactful. And so that's really the goal. I think later on in slides, a lot of times we'll talk about, the manufacturing aspect of it, why it's so important in our states that we live in and work in. And then we also want to make sure that they know that there's lots of options to get into making. And it could be a hobby at a makerspace. It could be a technical school or a trade school, and it could go all the way up into a 4-year college along those lines. And none of those are wrong or bad. They're all just different, and they all grow at a different pace. So that's why we have a little graph at the very end, I think, of some of the cost of entry to some of those things. And we have some pictures of physical space there, different things where we were able to host community groups, school groups, homeschool groups. And then, the paths towards technology are really about go at whatever level you're comfortable with. Makers are, by trade, they're hands-on. They want to build things, break things, create things. And so that's where we say the thing that's called the KMA is the Kentuckiana Manufacturing Association School. So it's like a trade school, just about tool and die things. And the nice thing about those guys, they have 100% placement, and they pay for your education after school. And so not only are you making money, but you're getting paid to go to school. And then you roll those credits up to a community college is our Ivy Tech. Then we have a Purdue campus all the way up to the University of Louisville in our region. And you guys have different access points up there, but they're all stair steps. Hands-on, roll up the credits and keep going and constantly progress. or again, it can just be an amazing outlet for an adult, for a kid, for anybody to just express and have that creativity in them. So that's the meat of it. If there's any questions, the equipment list down below is what we have in our physical space. So when people, if they see the trailer or they see the mobile aspect of it and where can I go to use this equipment, that's where we'll point them back to. Well, the creator has this, the library has that, the school has this, and here are different avenues and places you can go to it. So Tina, that I think rounds out what I had. Happy to answer any questions or share anything else if you need.
Thank you, John. So our great news as the creatory is that John has agreed to help the Makermobile come to Lake County this summer. So for 2 weeks, we'll have our hands-on ability to introduce educators that are interested in making sure or ensuring makers can of all ages can get started, all our students in Lake County. So what I am going to throw in the chat is a Google form because we are actively seeking anybody involved in education in Lake County is invited to become a part of our cohort and come see the Makermobile in person. And hopefully we will have an opportunity. And the plan is we will have an opportunity to work together for at least a week to get started on plans for our school year and what that would look like for us. The creatory also, of course, is looking for anybody interested in bringing a makerspace to Lake County. That is somewhere between our wonderful library spaces and hopefully somewhere to something like MHub or MXD to provide our students. The other thing we are looking to do while the Makermobile is up here this summer is to actually get started on a middle school, high school mentoring partnership where middle school students can be partnered with a high school student in some sort of maker education or similar track, and so that these young students can see exactly where this education can take them, like we've said, with the manufacturing and of course CLC's programs that could get them there. And I look forward to talking to as many of our viewers as possible. Thank you, Jan, for having us today.
Tina, thank you, and John and Dane for joining us, and really like kind of that peek into other people's spaces. I'll be sharing out your Google form when we post the videos later, and we can also put it with your profile on our main Maker Faire page. Right now, the chat is not going out to everyone. A lot of people are watching live, and so they're not seeing that. So we'll go ahead and make sure that gets out there later.
And of course, it's available on our website, thecreatory.org.
Okay, great. Once again, thank you for coming and sharing your information. And as we wrap up our day, I really want to thank all of our presenters that came today. It's definitely, our first Maker Faire for Lake County as a whole. I think we're off to a good start of making some really great connections. I was really kind of resonating with what John was saying, that we have these opportunities at, the university and college level to really take making into a career. We've got folks like MHub and MXD that you mentioned that help individuals or businesses look at how digital manufacturing and new ways of technology fit into, things they've done before. And then finally, we've got where Dane was showing, the spark of third grade and fourth grade on how can we leverage all these really cool ideas and not just make what the person next to me is making, but put my own spin on it and get their hands in, not just watch somebody else or come with a prefab kit, but make it their own. And I think these connections that we've made today among the presenters and hopefully all of our attendees will just continue to grow. And next spring, I know Dane mentioned, hopefully in March, they'll be doing their school fair. We're certainly hoping to do Maker Faire Lake County next April in person as well. And so I think we can just continue to showcase the great things that are happening in the area. And so once again, I thank the three of you for joining us this afternoon.
Thank you so much for having us.
And with that, I think we'll just kind of wrap things up for the afternoon. Once again, I want to thank all the presenters as well as our students from the Innovation Lab who shared their talents this afternoon. We have an opportunity really to kind of celebrate our students who participated in the different contests. I encourage you to go out to make projects and view their submissions. The Lake County's robotic competition was on track 2 earlier today. So if you didn't happen to catch that, we'll watch the recordings later. This is something that's going to be an annual thing. So certainly if you're interested as an individual or as a school, I encourage you to learn more about it. Coming up next week, April 24th to the 30th, CLC is going to have a virtual open house. So once again, trying to make those connections between what interests you and the careers that are out there. Make projects has a lot of great things posted that you can continue to interact with after this event. There once again are some of our great logo contest winners. The rocket launch is probably just winding up right now out in the parking lot. And once again, we hope to see you again next year. Our save the date is for April 9th, but we'll certainly be reaching back out to you and confirming that date once everything is set. So once again, thank you to all of you for joining us today. We hope you really learn some new things and have some new creative ideas for making. And I'm about to close everything out. I see we've got a few people still left in the attendees. Does anybody have any questions for us before we close out this webinar? So with that, we'll simply say, hope to see you all next year.